Hello everyone. Welcome, good morning. Thank you for being here. I think we're going to get started now because I think it's just gone 10. So, is that positioning of the microphone better? Is that better? We happy? Okay. Yes, they've done it for me. Wonderful. Welcome everyone to the second annual Transparency.dev Summit. Thank you so much for being here. I think we've got a lot of people from a lot of different places. Some people have traveled very far. I think the furthest distance that someone has come is we have one person that's come from Japan, so thank you. And I know we've got a lot of people from Sweden as well, so that's the sort of range of travel distances that we have. It's great to see everyone. For those of you that, I think everyone knows what this event is about, but it's so nice to be able to bring together this community of sort of implementers and operators of transparency systems, who real world practitioners of transparency, and actually get together in person and be able to talk in person and see each other in 3D and not just through the sort of the video screen. And the thing that I've been saying to everyone is sort of find out how tall each person is, because that for me is always the surprise. No, I think it's such a nice opportunity to be able to get together and discuss what's currently going on in the transparency space. And for me, it's like I wasn't able to make last year's Transparency.dev Summit. I wasn't part of the community at that time, but I was previous to that when it was more just about certificate transparency. And it's amazing to see what this event has become. What started as just like maybe a day or two certificate transparency specific days just with whoever was kind of local, and it's built into this amazing event. So yes, it's wonderful to see it, and we should have a good time. We've got a pretty good schedule for you. But before we get to the schedule, there are a few bits of admin that we've got to go through. The first, most important thing is I want to say a huge thank you to Glasklar, the hosts, who have done a lot of the funding and organization for this event. So a big round of applause for our hosts would be great. In addition, I would also like to say a huge thank you to our sponsors, Google, Chrome, Chalmers University of Technology, the University of Gothenburg, and Trail of Bits, who have all provided funding and, again, helped to make this what it is. So a big round of applause for them as well, please. So before we get to the fun stuff again, a little serious note about being good humans. This event does fall under the purview of the Transparency.dev Code of Conduct. It's basically just be nice to each other, be excellent. We are very fortunate. We do have a wonderful community, and we very rarely have issues with this, but it's just an FYI. If you do want to check it out, we have a QR code that it turns out if you generate them with Chrome, they end up with dinosaurs in them. And that's the site if you want to check it out, but just sort of FYI. On that note, if anyone has any questions or problems, not just someone's behaving badly, but like anything, if you have any question, anything like that, there are a few different people you can come to talk to. Obviously, there's me. I don't think I've even said my name. I'm Kat. Nice to meet you all. You will have... Thanks. You will have received emails from me, I'm sure. You can come to me with anything. I'm here. This is what I look like. We also have Annalie and Marie, who have been on the organizing team. And there's Al has volunteered to help for this. And Rasmus, where is Rasmus? And Rasmus is over there, and I will tell you more about him in a moment. These are all the people. We all know what's going on for the most part. If we don't know what's going on, then we know who to send you to find out what's going on. Come and chat to us if you have any issues or questions. We are friendly people, I promise. On that note, to do with, you probably met Annalie and Marie when they were giving out the lanyards and the T-shirts. For those of you, if there's anyone here who didn't get a T-shirt and was confused why you didn't get a T-shirt, they were for people who registered early. That being said, we did order some extras. So if you don't have a T-shirt and you would like a T-shirt, once everyone's properly turned up and registered and everything, that we will be offering the extras. So do let us know, like if maybe tomorrow or something, we'll go out there and we can stand out there and people can come and get one if you want one, because it would be really nice if everyone who wants one could get one, I think. Okay, next point. Slack. To chat to each other whilst we're here, we've set up a Slack channel, Summit 2025, nice and catchy. So I think people have already seen that. They've already been using it to do things like arrange drinks in the evenings. Last night people were using it to arrange dinner, people who have transport plans, like to chat to other attendees of the conference. Anything you want to use it for, it's there. Please go use it. As I think many of you are aware, but in case you're not, we are currently, I think, live streaming the event. If you want to send the link to anyone, this is the only use for having this slide that I could think of. That's the QR code for it and the live stream. Obviously, you're here in person, and the people who are currently watching on live stream have already found the live stream link. But we are being live streamed. That being said, I'm aware there are some people that didn't want to be on camera. I know the red lanyards are one thing. The red lanyards won't be being taken into account with the live stream so much because it's live. If you definitely don't want to be in camera, you can see the cameras are here. We would recommend sitting like behind them or in line with them, and then you won't be in the shot. The red lanyards we will be taking into account if we're taking photos, and we won't publish any photos that have people who are wearing red lanyards in them. If you are not wearing a red lanyard and you are now thinking, oh no, I really don't want to be in photos, feel free to come to us. We can switch your lanyard color out for a red one. We have some extras. Okay, admin about the venue. Where are the toilets? The toilets are basically, if you go through that wall and through the next wall, with all your walking through walls powers, that's where the toilets are located. The actual way to get there, out at the front, turn right, down, and then turn right again, and the toilets are there. On the floor below, they're in a very similar place, just one floor down, so round the side of the reception. Fire safety, if there's an emergency, fire exits. It turns out this building has an obscene amount of fire exits, so that's good. If you don't manage to find one, I would be shocked. There's one right there. That's the quickest way out of this room, take you downstairs, outside, out of the building. You can also, the signs are all there, out straight down the main stairs, out the front of the building. There's also another one back in that corner of the building, so any of them, if the fire alarm goes off. Wi-Fi, there is Wi-Fi here. If you haven't found it yet, I think it's just called Quality Guest. Use that. In terms of logistics during the day, we will be having morning and afternoon breaks, which will be located where in the reception, where we had the registration in that area. There will be some food and some teas and coffees out there. The popcorn machine is up and running, and I believe after lunch there's talk of an ice cream machine. So that's, I think, very exciting. Speaking of lunch will be downstairs in the restaurant. For those of you staying at the hotel, it's maybe where you had breakfast this morning. We will all be going there together. All of this is included in the conference. You don't have to pay anything like that. So we'll direct you at that time. One thing to note, if you have bags with you, in the evening and during lunch as well, this room will be locked. So, and you can still enter it, but you have to go and ask reception for access. So if you are leaving bags in here, bear in mind it may, you may not be able to get in during those times without a little bit of extra faff. What else do we have? Yes, so in the schedule, you will see that this evening we don't have any conference scheduled activities. We encourage you to make the most of the free time. There are a selection of activities in Gothenburg that I have been informed of. Things like, what have we got? There are things like, there's something called Prison Island. Don't know what that is. There's sports bars. There's a bar that has a lot of different games in it. Things like bowling, shuffleboard, pool, darts. There's go-karting. There's some sort of laser quest thing. I will send out on the Slack a list with the links to these places if anyone wants to go and do one of these activities. I recommend, on the Slack, getting groups together if you want to do that, or if you just want to go for beers, that's fine too. If anyone's here by themselves, please do talk to people. Come and talk to us if you don't have people to talk to, and we can introduce you to other people. If people are making plans to go out do things this evening, please do put it on the Slack and encourage others to come and join, because this is a community event. We want people to really be able to get together and socialize. And it would be such a shame if someone sort of did the conference, like, oh, that was fun, and then this evening was like, oh, I'll just go off and have dinner by myself. You might be jet lagged. If you want to do that, that's completely fine. But just in case, please try to be as inclusive as possible if you are making plans for this evening. Tomorrow evening, we have a dinner booked for everyone at a restaurant, which is just a 6-minute walk from here. Again, it's all included in the conference. So that will be exciting, and we will do that. And I will tell you more about directions and stuff. We'll do that tomorrow. Okay. The schedule. The schedule is awesome, and the next big thank you that I want to say is to our program committee, who have put in a lot of hours to vet talks and provide feedback and put the schedule together. This program committee is led by Rasmus, who gave a wave earlier and still here, and Martin, who unfortunately can't be here due to some circumstances that were completely unexpected. But he will still be speaking later on today remotely, so we will still see Martin, and I believe he's watching on the live stream, so hi Martin. So can we have a round of applause for our programme committee and programme committee chairs? So the schedule itself, today we have a day that is mostly CT based. I believe most of the talks are based on CT. We'll have our keynote first, very soon, once I stop talking, get off the stage. Tomorrow we've got talks on a sort of wider range of transparency topics. And then Wednesday morning, we do still have a few talks, and that's the key transparency slot. So it's all shaping up to look great. A few things that are in the schedule, if you haven't seen it, have I? There hasn't been a link to the schedule, has there? I've missed that. The schedule is on the website for anyone who wants to check it out. We do have some breakout sessions. So we have today and tomorrow, there are slots for breakout sessions. Now, how this is going to work is, for anyone who doesn't know what a breakout session is, it's basically we'll get together in little groups to discuss specific topics, specific questions. We don't have ones already planned. We want to know what you guys want to talk about, basically. That's why we're here, to talk about things that would be useful for the community to discuss in person. So if you have ideas for breakout sessions, starting basically now, I mean, maybe during the break, starting from the break, if you go to those whiteboards at the back of the room and you write down what your breakout session, what you would like to talk about on there, if you could leave a bit of space between each topic that you write, that would be great. Because what we will do is we'll do that throughout the day, and then about 15 minutes before the breakout session itself, I'll get everyone, we'll read out what the topics are, we'll get everyone to go and put a dot next to one that they want to attend, so we can then sort of split people up and put them in areas that fit the number of people that want to attend that breakout session. Does that kind of make sense? I will go over this again just before the breakout sessions, but that's the plan for that. So have a think about topics. In terms of what makes a good breakout session, it's better if you can come with a specific question or a specific problem. So instead of being I want to talk about CT, I want to talk about certificate transparency, it could be something like, okay, these logs are getting bigger and bigger. How do we start dealing with the log size as certificate lifetimes are getting shorter, and so the quantity of certificates is getting that much bigger? That would be a much more specific thing, like a problem that needs solving. So yeah, try to frame it as specific questions and problems. And the way the breakout session will be, there will be a period of time, I think it's 45 minutes today, an hour tomorrow, of discussion, and then we'll come together at the end of it and have a collective summary where we'll hear from someone from each of the sessions who will tell us key points of what was discussed. Another thing that we have is lightning talks. That slide is brighter. Oh, lightning talks. There are lightning talks throughout there are shorter talks that have been scheduled throughout the conference, but on Wednesday, we have an unscheduled lightning talk session. And this is basically if you think of something that you'd like to just come up here with no slides, no preparation needed. Come up here, have a little, tell people about. You can do that on Wednesday. If you'd like to sign up for the Lightning Talk slot, come and tell me or Al in red. This is how Al's waved a couple of times now. He's one of our delegated people. He didn't want to wear the attire, so he's the one in red. Or Rasmus, who has waved a few times now. And we will jot down what you want to do. I think the full slot is 45 minutes, so how long you have will depend a bit on how many people we have wanting to do it, but we think it's 2 to 5 minutes, not super long. And finally, I've been talking for too long, haven't I? On Wednesday we have a quiz. Those of you who were here last year may remember there was a quiz. There will also be prizes for the quiz. The quiz will be based on the content of the conference. It will be based on the talks. So pay attention to the talks and you may do really well in the quiz. And with that, I think that's everything from me. Like I said, if you have any questions or problems during the day, please come and talk to us. I have actually just remembered one thing that is very important. Speakers, people who are speaking, what we need you to do is, hopefully you know where on the schedule you are. If you can look to before, there are breaks throughout the schedule. During the break that is before the block that you are speaking in, if you can come and see our lovely production team, and they will sort you out with sort of checking that your slides and everything are going to work, and with a microphone. So, for example, if you're in the block directly after lunch, come and see them during lunchtime, probably towards the end of lunchtime, but ideally not just 2 minutes before. Like, give it a little while, because there are a number of speakers in each block. So yeah, with that, I think that's everything, and I will hand over to Filippo, who's going to give our keynote.
Thank you. All right. Hello, everyone. It's great to see a bunch of known faces, bunch of friends. Also, hi, Martin. And it's great to see a lot of new faces, because indeed, I'm glad that this technology is growing, that this community is doing great. So we're going to talk about the T-Log ecosystem. We're going to try to go over a bunch of different things that are happening, and talk about how they fit together. Because I feel like at this point we're getting large enough as a community that people that sit over there don't necessarily know what people that sit over there are doing. So, since we do have new people, a bit of introduction. I'm Filippo. I've been one of the maintainers of the Go cryptography standard library since 2018. I've worked on the Go checksum database with Russ Cox when I was still at Google. I've left Google in 2022, and now I run organizational professional maintainers, which is not the topic of today. Anyway, I've worked with the SIGSAM folks on the SIGSAM specification and on witnessing. I've worked on Sunlight. I've worked a bit on photosynthesis, although that's mostly the work of the Chrome folks. So, let's start by just talking about what is this about. We all care about transparency, but like, humor me. Let me give you my version of how I think about transparency and why I'm excited about it. So what we're building is globally consistent append-only lists. We're building these magic lists that if you're the owner of the list, you can add things to it, and then magically it will be in everybody who looks at that list will have that full list of append-only entries. Okay, what do we do with it? What we do with it is that we can bring accountability in places where trust is either not sufficient or too hard. We've been trying to bring strong trust to package ecosystems forever. Like, oh, we'll get people to manage their keys, and they will sign releases of their software, and will only accept things that are signed. And what happens if they lose their key? Well, issue. And from the other side of the spectrum, we had, well, we'll just have a central entity, a registry that will just publish the things, and we'll just trust it, right? And they can always sign it, so we can have that registry just put a signature on everything it publishes, so that at least it's offline verifiable and it has no repudiation properties. That was still not satisfying, because, for example, the Go community doesn't necessarily trust Google to tell it the contents of every single package, right? So that's what makes me excited about transparency. Transparency is a tool to both capture the efficiency of centralized systems, like having a central mirror for all of the Go packages, and at the same time providing accountability for the entity that publishes those, without having to go all the way to the full trust of putting keys in the hands of developers, which are definitely going to misplace them, and so that will need some break glass mechanism, which will essentially bring the whole thing down. So that's what those magic lists do. When we have a magic list that you can add entries, and once you add an entry into the list, it's magically everywhere. We can hold the list owner accountable for what they put on there. And that's both easier than strong trust and stronger than just blindly trusting the operator. The one thing is that it needs a monitoring story. You know what animal I'm thinking about. Okay, we'll get to that, but the one thing that is still necessary to make this work is that somebody needs to look at the list. Even better, when designing the list, there needs to be a believable story for how somebody would go through it and say, what's that entry? I didn't publish that. So there needs to be a way to actually look at that list and call out and use the accountability to call out the list operator. Okay, so a bunch of stuff you've already heard. The point about monitoring, I really like what Alex Gaynor says about signatures and backups. You probably already heard me say this, but just like backups without recovers are useless, signatures without verification are useless. And in the same way, logs without monitoring are yes, fantastic. Thank you. It is early morning. I get it. I truly appreciate it. All right. So let's talk about the tools we have and how they fit together. Let's start at the bottom of the stack. Let's start with specifications. Specifications are the layer we sit on top to interoperate with each other to build tools that are reusable. So the original one, RFC 6962. Everybody can say these numbers by mind. We ascertained at dinner yesterday. Truly, the last thing we're using from RFC 6962, I think, is the Merkle tree. So the actual specification of how to take a list and hash it all into a single hash at the top with efficient inclusion paths into it. So maybe we should extract that? Unclear. Anyway, that's where we started at 10 years ago, and then we slowly moved piece by piece. So the core interoperability tool of the tlog ecosystem is the checkpoint. The checkpoint is nothing else than the signed tree head. It's a name for the log, so that we have an identity, origin line, which is the thing that witnesses, for example, will index logs by. A size, so a specific size of the append-only log, and the hash of the tree head, which is the hash at the top of that Merkle tree. It's a signed note, which is nothing else than inline signature format for textual data. And it will have co-signatures by both the log and witnesses that essentially say, yes, that is consistent with everything I've ever seen from that log based on the origin line. So witnesses, how do witnesses talk to each other? That's the other aspect, tlog witness. Tlog witness is instead not a format, but a protocol. It's a protocol for logs to say, hey, I made a new version of the log, which is longer. Here is the new version. Here is a consistency proof with the previous version you've seen, dear witness. Please give me back a signature which says, yep, I confirm that this is consistent with the previous version I've seen, and I will remember the new version so that anything I sign in the future will have to be consistent, append only with what I've seen. So we've got the checkpoint, which is the interchange format between these entities, and tlog witness, which is how they talk to each other. Co-signatures don't have to only have the semantics of, yep, I have checked that. I have checked consistency. The good thing about checking consistency is that it is extremely low in terms of resources. A witness has fixed state per log because it only has to remember essentially the last checkpoint it has signed. It needs to remember the log name, the size, the hash of the last thing it's seen, and arguably the signature so that it can prove why it cosigned the thing it cosigned. But we could also want, for example, a cosigner that says, yep, not only have I checked consistency, but I've also had received a copy of the entries in the log. And that's what tlog mirror is for. We can come up with other things that cosigners can do and other semantics to attach to the specific cosignatures that specific entities do. But even T-log mirror uses this protocol as the base to exchange checkpoints, and then it has a sidecar endpoint to receive the actual entity, the actual entries before it produces the cosignature. Finally, how do we serve the log? Because so far we talked about the format for a log tree head. We've talked about how they exchange synchronously with witnesses. Finally, T-log tiles is a way to serve the Merkle tree and the entries at the bottom of the tree as static entities, static artifacts, so that they can easily be cached, so that they can easily be mirrored. So T-log tiles is extracted from the Go checksum database designed by Russ Cox, and essentially works by cutting the Merkle tree up into tiles, dropping everything that's not the bottom row, because you can always hash things up to recover those, and serving those as static files. Great. So what do we miss? We have a couple specifications that we still need to complete the picture. One is a specification for the actual proof format. We do need to prove to someone that something was included in a log. And I like to call these spicy signatures because we can make these offline verifiable. And our offline verifiable proof is nothing else, fits very neatly in a digital signature slot. Because if you think about it, a digital signature is just an offline verifiable proof, publicly offline verifiable proof, where given a public key and a signature that certifies a message. So the message is the thing that's in the log. The public key is the policy of which witnesses need to cosign a checkpoint. And the signature is this. The signature is nothing else than at what index in the log is this entry, an inclusion proof up to a checkpoint, which has witness cosignatures. And I like to put a context hint at the bottom because it's useful to have a little information that can get hashed, for example, into the leaf. For example, if you're signing a file, it could be the file name. If you're using a log that has a context field, it can be a context field. This also fits in the digital signature box because modern digital signatures have an additional data / context field. So I think that's a good idea, but anyway, this does not exist yet. We do need to specify that. SIGSUM has an offline proof already, which is pretty SIGSUM flavored in that it uses key hashes. But this is something that I'm planning to work, and I think we should get to. And then once we have the signature, we also need a public key format. And the public key format is nothing else than a policy of which witnesses need to cosign something in order for it to be acceptable. SIGSUM already has a policy format. I think Tessera already supports the policy format for configuring logs, because logs need to know which witnesses to go ask to. And I think this one just works, so great. And it is also nice how specifications have converged from different places, from different venues, the IETF, C2SP, SIGSUM, and we're finding ways to work together and interoperate. Great. So we have a substrate of shared specifications. On top of that, we can build shared code. There are packages. The original Go checksum database packages have held up pretty nicely. The main difference is that they have configurable tile height, which we kind of did away with because everybody was using 8, and 8 is a nice number, so we're just going to keep that. And then there's Torchwood, which is nothing else than a library of useful tidbits and things for working with the specifications we just talked about. So this is more for the library point of view. And by the way, I'm very happy to take PRs to Torchwood because it is intended to be essentially an extension of the tlog and node packages, which are sort of frozen and Go specific. But they share types with the Go packages. So this is libraries. And then there's Tessera, which is essentially the generic log implementation. And to be clear, in case it's not clear by now, I'm not talking about stuff I did here. I'm talking about stuff that everybody in the community did. And case in point, Tessera is built by the Trust Fabric team at Google. So Tessera is a library and a service to run tlogs that follow all of the specifications we talked about. They support witnessing, tlog tiles, and so on, and that can store the log in things like S3, GCP, or local POSIX file systems, which is what we're big fans of. I think there's a talk by Philip and Roger today about Tessera, so I will not spend that much time on this. Okay, so we've got specifications, we've got code to work with them. We still need something on top of that, and that's shared infrastructure. This is something pretty special about transparency, in that the hard part is the part that you can't build alone. Usually systems, you can just build your thing, and at worst, you are interacting with a peer. Like you're implementing TLS, you still have to think about what the peer will do, but you're doing your implementation. For most services, you're just building a thing. Transparency, by and large, unless you are in one of those cases in which gossiping works, you generally need third parties for that witnessing that we're talking about. Witnessing lets you lets transparency protect the system that would be the same system that would do the gossiping. Anyway, so the hard part, by and large, of any of these projects is not the engineering. The hard part is when you get to the end of the project and you're like, well, then we just need to get the third parties. And the lawyers start asking, wait, what do you mean? And the SREs start asking, wait, what SLA are we getting from those third parties? And that's the hard part. So I'm very happy about two things. One is the public witness network. We've been talking about this for a while. There's now a website you can go to. And what you'll find there is two things. One is a table of public use witnesses. This is the table of testing witnesses because the network is in the testing phase. And these are public benefit witnesses, witnesses that are operated for the witness ecosystem. Why is this possible? Philip, are we building another city ecosystem where incentives are not clear? Well, witnesses are cheap. That's the trick. So we're not asking the organizations that will run these public use witnesses to expend large amounts of resources. They just have to stake their reputation on not being malicious about how they operated, and ideally to operate them for long enough that there's not a bunch of churn. So you'll get a list of witnesses, and what do these witnesses commit to? They commit to configure a list of logs. So if you have a log and you want to get witnessing for this log, you can request your log to be included in this automated configuration file, which will get shipped out to all of the witnesses that are part of the network. Then you configure your policy for a subset of the witnesses, the ones you trust, the ones your community will trust. And now you have solved that third-party problem using a quorum, so you are not relying on any specific witness. Great. These witnesses are already implemented with a number of different implementations, which I'm pretty happy about because it's not a monoculture, and that's downstream of how the witness job is, again, cheap and pretty simple in terms of specifications. We've got light witness, sunlight is also a witness, there's the armored witness, there's omni witness, developed all by different teams. Okay, so that solves the witnessing part. Some projects don't even need or care to run a whole log. I think we actually made it very, very easy to run lightweight logs that then use the witness ecosystem. And you don't even need to run a service to run a log. You can just have a POSIX file system backed log. But in some cases, you can go even more lightweight. And that's using public log multiplexers. You might already know about SIGSUM, about Record, but why am I calling them log multiplexers? I'm doing that because if you squint, SIGSUM, for example, is a system where you sign something with your ED25519 key, and then you send it to SIGSUM. And SIGSUM will store two things in an append-only log: the hash of the public key that did the signature, and the hash of the thing that was signed. If you think about it, what you're doing is that you're making a sublog. You can carve out the log of things signed by a specific key. And there isn't really a semantic difference between taking Tessera and running your own log for those entries, or signing them with a public key and sending them to a SIGSUM log. You are still creating a magic append-only globally consistent list of entries that you are responsible for. In one case, you're also operating the log. In the other case, you're delegating the log operation to a log multiplexer, which is SIGSUM. Record is similar, except the identity, the way that the log is multiplexed based on is not public key hash necessarily, but also supports OIDC identities. So essentially, you log in if you squint in a way to Record with your OIDC identity, and then you give it attestation or an artifact. It's specifically geared to software supply chain, but conceptually you're still logging in, adding something to a log that can be demuxed into just the list of things that were signed by the specific identity. Cool. So this is also a fantastic shared infrastructure that's available for projects that don't want to even take the overhead of signing up for the witness network. Great. Okay, so let's briefly talk about the things built on top. This was all of the stuff that the substrates we have, the specification, the code, the infrastructure that let us build Transparency. Now, the one that I care deeply about, of course, is the checksum database. A checksum database is, we talked about at the beginning, is just a list of all of the versions of the packages, of all the packages in an ecosystem. All the packages. That's the beauty of checksum database approach. On day one, the Go checksum database had 100% deployment because we just turned it on. And everything that was fetched by the Go client had to be in there, and Google would just fetch the thing, hash it, put it in the checksum database. If Google were to lie, Google would be accountable for it. It also had no operational issues, no key rotation issues, no key compromises, nothing since day one, which is not that hard because it's just a list, but that's the point. If we were to delegate keys to operators, that would cause a lot more issues. I'm excited for other package ecosystems to do similar things, and I think Hayden is going to talk about that. So I'll let him talk about it in his talk. The Go checksum database also has a monitoring story that I'm very happy about. And that's GopherWatch. GopherWatch is a third-party, completely community-operated, built by Mikhail, who will, again, talk about it, I think, tomorrow. And you can sign up and get an email every time a new thing under your package name shows up in the checksum database. So that keeps the checksum database honest. Then there's key transparency. Key transparency is a deep field which I don't claim to be an expert in, but often and again, key transparency then has a problem at the top, like fill this gap here where it says, well, we also need a way to make globally consistent the list of epochs. And there are some amazing solutions to that. For example, we'll just pay Amazon to make the S3 bucket a retention bucket, which, I mean, honestly love. But also we just built a magic list of globally consistent entries. So, you know, if you're building key transparency. We've got a couple excellent talks on key transparency, one by Brandon, one by Melissa. So I'll let them talk about that. Certificate transparency. Certificate transparency got it all started, which means has a lot of legacy. There's static CT, which is an attempt to move the to move CT into the specs we just talked about. Static CT API is really TLog tiles with a mustache on to improve compression. It uses TLog checkpoint. You can do witnessing to it, and Tesseract actually shipped that before Sunlight, which I'm extremely happy. And there are a number of implementations already, so Sunlight, Azul, Tesseract, and more. Even more exciting is Merkle tree certificates. There's a talk by Joe on this, so I'm not going to go deep into it, but this is probably how we would build CT today using all of the things we have. It removes SCTs and replaces them with spicy signatures. It actually moves the logs into the purview of the CA, which is the one that's actually adding the entries, which also removes duplication, which means the same cert doesn't have to be in a bunch of logs because the CA is the one that publishes it. And it does nice tricks to reduce the entry size because you can do a lot of things if you think hard about what you put in the log entry. There needs to be enough to help monitors, but everything else can be hashed if you don't need monitors to know about it. All right. Firmware, again, excellent talks by Frederick and Andrea and Billy Lowe, so I'm not going to go deep into this, but the fact that we have offline verifiable proofs makes them work on things like bootloaders and firmware. CLIs, I'll probably take a line in talk to talk about that. I have finally built a thing and I called it spicy. I wanted to call something spicy for a while, you know that. All right, and finally, what new things are coming? We've got new applications coming down the line. We can think of about a number of things to build on top of these substrates. We can build logs of Git pushes, of websites, social identities. Blue Sky has this PLC thing, which is basically shaped like something that would fit in transparency. Again, Michael Rosmer and Dennis Jackson are giving a talk about web transparency, so I'm excited about that. And then more monitoring. Here comes the owl. We are not building enough monitoring tools. We need monitoring that's reliable, that is silent. And Rasmus is going to talk about silent CT, and he'll talk about what we mean with silent, something that doesn't tell you unless something went wrong. And verifiable. Which instead is Martin's talk. I'll let him talk about that, but this might be the last substrate piece that I think we need, that I'm very excited about, because this will make it efficient to do things that right now require fetching the entire log. And that can be figuring out which versions of a package are in the Go checksum database. That can be demuxing a multiplexed log like SIGSUM. Right now you have to fetch an entire SIGSUM log with a verifiable index. You could just look at the entries that are relevant to you. And for CT, of course, not fetching the whole log from the poor CT log operators, which pay for bandwidth through the nose. Not us. We are not in the cloud. Anyway, all right, this is it. Thank you very much. And I am so looking forward to this event. And thank you all so much for coming. Thanks, Kat, and thanks, Glassclar, for organizing this.
Well, good. Round of applause for Felipe. I think we do probably have time for maybe 1 or 2 questions, if anyone has any questions for Felipe right now. I mean, if not, we'll go to a break. Everyone wants a break. Okay, thank you again, Filippo. So now we're going to have just a short 15-minute break. I believe there might be treats out there. I'm not sure what they are. Is there stuff out there? There's stuff out there. Go see what it is. It'll be a surprise for all of us. And we'll be back here at 11 to get started on the next set of topics. For any speakers who are in the next set, if you could, during this time, come and speak to the production team to get mic'd up, that would be great. Hello again, everyone. Welcome back. We're going to get started again, I think. I hope everyone, I've now been and seen what snacks there were outside. It's quite a lot. It's quite a lot of food. Please do eat as much as you feel. We have a lot of food, it seems. Also, something to note, for those of you who did fill out the registration form saying you have dietary requirements, if you... we are providing for dietary requirements. If you're vegan or gluten-free or anything like that, we have them. I think at the moment, there were the sandwiches, there were turkey sandwiches, but if you went all the way down to the end, there were options there. Just want to make you aware that they are there, in case you just glanced and were like, oh, there's nothing for me. There is. We are providing. Yes, so with that, we're going to move on to our first big talks session, which is on real-world lessons and insights. And we're going to start with Andrew, who's going to tell us about his experience learning from failures in certificate transparency.
Oh, thank you, Kat. I just want to say it's really wonderful to see so many familiar people here today. I'm really glad to be here. So for those of you who don't know me, I'm Andrew Eyre. Since 2016, I've operated a certificate transparency monitor called CertSpotter, and I've sent quite a few emails to the CT policy mailing list talking about various ways that certificate transparency logs aren't working right. And today, I'm going to talk about that. So why do we care about certificate transparency log failures? Well, anytime a CT log fails, it creates a risk that domain owners might not be notified about certificates for their domains, and it creates a risk that previously issued certificates might stop working. Now, thankfully, this has never happened during the history of CT. But this is pretty much just luck. If the wrong combination of logs fail, then previously issued certificates will stop working. So this is really something that we want to avoid. Now, here's a graph of CT log failures over the past 10 years. In red are what I'm calling the fatal failures. This is every time that a certificate transparency log had to be retired. But I am excluding cases where the log operator intentionally shut down their log. And then in blue, we have what I'm calling the non-fatal failures. These are serious incidents like having a multi-day outage or violating the MMD that did not lead to log retirement. And I'm including them because even though the log wasn't retired, these were really bad issues, and they certainly could have led to the log being retired. And also, by the way, if a log operator had multiple logs fail at the same time for the same reason, I'm only counting that as one failure here. So in total, we've had 23 failures over 10 years, which means that on average, it's more than 2 failures per year. And I really think that number is too high. So let's look at all of these failures and see if there are any lessons that can be learned to hopefully prevent similar failures from occurring in the future. So here are all the ways that certificate transparency logs fail. The most common failure mode we've seen is unincorporated SCTs. This is where a log receives a certificate from a submitter. The log issues a signed certificate timestamp, promising to include the certificate in the log, but then it just never does so. Now, that's a really serious violation of transparency, so consequentially, every time this has happened, the log has been retired. So then the second most common failure mode is an MMD violation. This is where a log receives a certificate, it issues an SCT promising to include it, but then it fails to include that certificate within the 24-hour maximum merge delay deadline. Now, in these cases, the certificate does eventually end up in the log. So for that reason, there is some discretion available here, and it's possible for the log to continue operating once the certificate is in the log. And for that reason, all of these failures have actually been non-fatal. A log has never been retired purely for an MMD violation. And then equally common to that has been multi-day outages. And these are more severe than an MMD violation because not only are recently logged certificates inaccessible, but actually the entire log is inaccessible. And 3 of these have been fatal, and the log has been retired, and 2 of these incidents have been non-fatal. And then after that, there have been 4 cases of a log signing an inconsistent tree head. And in this case, what happens, the log issues this tree head, but the log is unable to produce a sequence of entries which hash up to the hash that's in the tree head. And now, since a log is unable to take back an STH after it's signed it, these are always fatal errors that require the log to be retired. And then there's been one failure of the log operator just losing the data for the log. That, of course, is fatal. One case of an inconsistent entry. This is where the Merkle tree is fine, but there's an entry in the log that doesn't make sense. An example of this would be if a pre-certificate doesn't match the TBS certificate in the Merkle tree leaf. And this has happened once, and it was fatal. And then there was one instance of private key compromise for log, and that, of course, was fatal. So what I did was I looked at every one of those failures, and I tried to identify a root cause for it. And at the top, tied for most common, was the use of asynchronous merging. This is the practice of a log returning a signed certificate timestamp for a certificate before that certificate has actually been merged into the log. Equally common has been the log using the wrong storage model. And then there were 4 failures where the log operator didn't provide a good enough incident report, so I wasn't able to figure out what really happened there. But interestingly, every one of those 4 failures was actually an unincorporated SCT. And I think that quite likely the root cause for those was also asynchronous merging, and I'll explain more in a moment. Then there were 2 cases where the log failed because configuring it was more fragile than it needed to be. There were 2 instances of cosmic rays, which is just a cheeky way of saying there were bit flips in the log and no one knows why. And then one case of the operator doing administration manually, one case of the log operator not having enough resources to operate a reliable log, and then there was one security compromise. I'm going to focus just on the first 4 here because they are the most common and they have some really great lessons to learn from. So, traditionally, the way that certificate transparency logs have worked is that someone submits a certificate and the log returns immediately a signed certificate timestamp, promising that at some point in the future, hopefully, that certificate will be added to the log. And in the meantime, the log just sticks that certificate in some queue somewhere. And this has caused some problems. And the first problem this has caused is that it enables logs to accept certificates faster than they can be merged. And this is because issuing an SCT and adding a certificate to a queue is a fast, parallelizable operation. But actually processing these queues and merging these certificates into the log, that's slower and inherently sequential. So there have been 5 failures over the years where a log has been unable to merge all of the certificates that are pending into the log within the 24-hour MMD deadline. And in all these cases, basically the same thing happened. A bunch of certificates, there's been a surge of certificates, submissions to the log, and the log just can't keep up. Then the other problem that asynchronous merging causes is that logs can accept certificates, issue SCTs for them, and then just forget about them. And this has happened 5 times. And we only got a good incident report from the log operator in one of these cases. And what happened there was that the queue of these pending certificates was being stored in memory. So that meant that when the log software restarted, all of these pending unincorporated certificates were just lost. Now, we don't know exactly what happened in the other 4 cases, but what I find really interesting about them is that the log operator didn't have any trouble storing the log itself. It was just this queue of pending certificates that, for whatever reason, got lost. And that just leads me to believe that this practice of having this queue of unmerged certificates is just inherently risky. And it's a bit surprising to me because you would think that in theory, if a log operator can store the log successfully, they should be able to store this queue successfully, but that just hasn't seemed to be the case in practice. And for that reason, I think that logs should not return an SCT for a submitted certificate until a new tree head incorporating that certificate has been signed and stored successfully. This has a number of advantages. Now, there are some downsides also. It does mean that it takes a little bit longer to submit a certificate. You might have to wait a second to get an SCT back instead of like 100 milliseconds. But the advantages, I believe, are just enormous. Because first of all, it provides natural back pressure. It's just simply no longer possible for a log to accept certificates faster than they can be merged. And then second, it fails safely. Because let's say that some problem occurs when the log is signing and storing that tree head. Let's say, for instance, it's using file system for storage and the file system runs out of space. So with asynchronous merging, even if you're durably storing those pending certificates, if there's a problem creating a tree head, then the log operator now has this deadline that they have to meet to go in and figure out what went wrong, manually process this queue of pending certificates, and make sure they get in the log. But with synchronous merging, what the log can do is it can just return an error to all of the pending certificate submission requests instead of an SCT. And then the submitter can go get SCTs from a different log. Chrome has recently issued guidance to log operators saying that if something's going wrong with your log, if you think there's a risk that you might not incorporate all your certificates, then you should put your log into read-only mode as soon as possible. And the nice thing about synchronous merging is that that basically happens automatically. If there's some problem publishing the tree head, the log just will stop, accepting entries. And then lastly, it's just simpler because now the log operator only has to worry about storing the log data durably. But with asynchronous merging, the log operator has to worry about both the log itself and this queue of pending certificates. So now let's talk about databases. Historically, certificate transparency logs have been built on databases like, say, MySQL or PostgreSQL. But I would argue that CT really doesn't need databases. If you think about what a transparency log is it's just this append-only, list where you're just adding stuff to the end. You're never updating, you're never deleting, and also you're mostly just retrieving, entries by their position in the log. So you don't need these features of databases. The other thing that databases are really good at is indexes, but certificate transparency logs don't really need indexes for basic read operations. So if you're operating an RFC 6962 log, you need two indexes. One, you need an index to prevent duplicate certificates from being added to the log. And second, you need an index to implement the getProofByHash endpoint, because this endpoint, it takes a leaf hash as an argument, and it has to be able to translate that leaf hash into an entry number. But just the basic getEntries call, which is the bulk of the read traffic to a log, you don't need an index for that, because it's just the numeric entry numbers. Now, static CT API, that does away with the getProofByHash endpoint, so you don't need an index for that. The only index you need is the duplicate prevention index. And the beautiful thing about the duplicate prevention index is that it's possible to lose some or even all of the entries in this index. Because the worst thing that can happen in that case is the log might accept some certificates that are already in there. So worst case scenario, you lose the entire duplicate prevention index, and your log doubles in size as every certificate gets submitted a second time to the log. And that's not ideal, but it's far, far better than losing the entire log. And then another thing, too, which I realized is that with Merkle tree certificates, where the certificate authority is the one operating the log, they don't even need the duplicate prevention index because they're the only ones submitting to that log. You only need the duplicate prevention index if you have third parties potentially submitting to the log who might submit duplicates. So instead of databases, keep your log entries in immutable number tiles on the file system or in object storage like S3. And the tlog tile spec that's used by static CT API provides a great blueprint for doing that. And the beautiful thing about static CT API is that you can then just serve these tiles using just a regular web server. But even RFC 6962 logs, I would actually benefit from using the tile format internally instead of storing everything in a database. Because, well, databases cause problems, and one of the problems with databases is that there are more things that can go wrong with them, and recovery is harder. In 2017, a log operator had a failure of their database that required recovering the database from backups. What I find interesting about this failure is that the backups were stored in object storage, and the backups were complete. There was no data loss because of this incident. But because the log was being served out of a database, the backups had to be restored from object storage. This was a complicated process. The operator made a mistake in the process, and they signed an inconsistent tree head, killing the log. And then recovery can be slow. In 2022 and 2023, we saw a log operator have multi-day outages because the database they were using had to be restored from disk into memory every time the log server started. And so what would happen is if all of the nodes in their log cluster died at the same time, then they would have to wait for the database to be loaded back into memory. And since the log was huge at this point, these were multi-day outages. And then in 2023, we had an operator suffer a multi-week outage of 3 of their logs because they too had a failure which required restoring their database from backups. And this was a long and complex process for them. And then databases can have corruption. In 2024, a log operator ran out of disk space on the partition containing their MariaDB database. And MariaDB handled this very poorly. It actually corrupted the table containing all of the pending certificates. So this led to the log having unincorporated SCTs. And now, certainly not all not all database software is going to handle that out-of-space condition as poorly as MariaDB did. But this just goes to show if you're using a database, you better make sure you're absolutely certain of what your database's properties are and how it's going to handle these fairly common conditions like out-of-space errors. So another problem with databases is that it's hard to scale reads. Quite a few log operators have had problems with this over the years, and there have been a lot of frequent short outages because of log operators not being able to handle all the read load. And in 2025, there was a multi-day outage of 2 logs by the same operator because their database couldn't handle the read load. And what I find really telling is that 3 log operators now have tile-based caches in front of their database. The way that these work is that as clients are retrieving entries, these caches are basically creating tiles on the fly and storing them in object storage. It's not the exact same format that tlog tiles uses, but it's basically the same concept. And this solves the read scalability problem very well, but I find it to be an unfortunate architecture because ultimately the database is still there, and if there's a problem with the database, those tile-based caches are probably not going to save it. So my thoughts are, if you have object storage and you're making tiles anyways, that should be the source of truth for the log, not a database. So lastly, with databases, you have a problem of low limits. RDS, which is Amazon's MySQL service, has a per table limit of 16 terabytes. This has already killed a test log, and a production log is coming close to hitting that. PostgreSQL is a bit better with 32 terabytes, but that's still a limit that a log could conceivably hit, especially if signatures get larger, the certificate issuance gets more frequent. On the other hand, if you're storing on the file system or object storage, the limits there are basically infinite. And finally, configuration fragility. In 2016, a log operator used the same private key for their test and production logs, which led to the production of inconsistent STHs. In 2020, a log operator configured their test log to use their production etcd cluster. This made the log software very confused. Writes went to the wrong place, and inconsistent tree heads were signed for 2 of their logs, killing them. So it's certainly not possible for log software to prevent all mistakes an operator could conceivably make, but I think log software should try really hard. And I want to talk about Sunlight's global lock backend. Sunlight is Filippo's static CT API implementation, and I really love the global lock backend. What this is a small database that's shared amongst all of the logs operated by an operator. And this database, it maps log public key to the latest tree head signed by that public key. So when Sunlight needs to add some new entries to the log, it starts with a tree head. It then adds the hashes for all of those entries to that tree head, and then has a new tree head. And before publishing that tree head, Sunlight will do an atomic compare and swap, in the global lock backend. And if the tree head that was previously there for that log key is not the tree head that Sunlight started with, that means that Sunlight was about to sign an inconsistent tree head, so Sunlight will just abort the operation. And this plays very nicely with synchronous merging because it means that any pending certificate submission will just fail with an error. And then the log operator can go and figure out what went wrong and most likely recover the log successfully. And this is just wonderful because it means the global lock backend means that as long as the log operator always uses the same lock backend for all their logs, Sunlight will never sign an inconsistent tree head, even if the operator reuses keys, and even if the operator accidentally starts multiple instances of Sunlight writing to the same place. And I think that's just wonderful. So, to sum up, my recommendations are: 1, logs should not return SCTs until a tree head is successfully signed and stored. And this means that if you're using Tesseract, you should not disable its publication awaiter. I think there's a bit of a misconception that static CT API forces logs to do synchronous merging, but in reality, it only forces synchronous sequencing. But it's still possible for static CT API logs to delay the publication of those checkpoints, and I think it's better, if static CT APIs did not do that, if they did it synchronously. And then second, store data in tiles on the file system or in object storage. And finally, log software should be as resilient as possible to config mistakes. And I think that Sunlight's global lock backend should be table stakes here. And I think that if logs had been following these recommendations, it would have prevented at least 12 and potentially up to 18 of these 23 failures I looked at. And I think that's great because I think this really sort of validates that the ecosystem is moving in a good direction with this new log software that we're making with the new T-log tiles spec. And I hope that that more logs, CT logs, will move towards using new log software with static CT API, and that will have a more robust ecosystem in the future. Thank you.
Thank you, Andrew. Do we have any questions for Andrew? I will bring you a microphone. Come on, yeah.
I suppose I'm already mic'd up, but I can use another mic. Yeah, so not really a question. I just want to say that right now, Twig, Let's Encrypt CT test log is currently having an outage because of the global lockend being down because of an Amazon outage. DynamoDB in US East 1 is currently down. So that's an exciting new failure mode caused by prevention of several other prevention modes.
I'll just say to that, fortunately, that's should just be a read downtime, right? Sorry, a write downtime.
It is just a write downtime.
Yeah.
Also, we deliberately put the test log in US East 1 and not a production logs there because of Amazon's history of that region.
How many logs were considered here? Like, I know the failures, but how many didn't fail, I guess?
Oh gosh, that's a good question. There are a lot of logs because every log operator, we have, I guess, 6 or 7 log operators currently, I think. Yeah, and each one's operating like 4 or maybe even 6 shards currently because of it's sharded by year, and then we've had a bunch of years since then. So yeah, it's a long-winded way of saying it's a lot that haven't failed, but I don't know the exact number.
Anyone else? Hands up.
Have you noticed any trends in the failure modes over time?
Oh, in the failure modes. Yeah, I would say that recently there have been way more MMD violations and extensive outages, and I think the reason for that is because there's a mysterious person who's copying certificates from one log into other logs, and that has greatly increased the write load on logs, and they haven't responded so well. But apart from that, no, well, actually, yes, I would say that the unincorporated SCTs, we haven't seen those in a while. Those were mostly in the first few years of CT's history. But yeah, good question.
Okay, great. So with that, let's give Andrew another round of applause. And I'm going to invite Matthew up, who's going to tell us about uptime as a CA or something, right?
Yes. Yeah, so a lot of people here have talked about running logs, but as an actual certificate authority, our experiences are a little bit different. Let's Encrypt is both a log operator as well as a CA, so I sort of get to see both sides of that, and we can talk a little about it. So first, who we are. So Let's Encrypt is a free certificate authority run by the nonprofit ISRG. And we issue certificates. That's the main thing a CA does, right? And so in order to do that, we need CT. And really, that means that we do a lot of logging of things to CT. A lot of the stuff Andrew talked about actually running and keeping the logs up is interesting. And from our perspective, we need to do a bunch of work to ensure that we can reliably log to them. For operators, why you probably care about us is that in terms of number of log entries, we produce by far a large portion of them. That's mostly because we're a free CA, open to all, so we issue a lot of things to a lot of people. We use the ACME protocol. It's standardized as an RFC. And in order to just sort of make sure everyone has a common understanding, I'll just give a really brief version of how ACME actually works, which is that we have an API, you get an account, you contact us to create an order with the sort of identifiers that you want on your certificate, whether that's DNS names, IP addresses, other things if you're not in the web PKI. We kind of go through a set of API requests to validate domain control, which is really out of scope here, but that's basically making some outgoing request to either DNS or directly to the endpoints to verify that the entity requesting it has control over those domains with a challenge. And then finally, there's an endpoint in ACME called finalize to finalize the order to take that pending request and produce a certificate. Really just a couple steps there. We sign a pre-certificate with our HSMs. We submit that pre-certificate to 2 or more logs to get back SCTs. We then take those SCTs, incorporate them into a new certificate called the final certificate, and then we also log that final certificate into CT. In our implementation, finalize happens synchronously. All of these steps happen, and notably, that means we're making outgoing requests from our CT to these third-party CT logs in our issuance flow, which is very interesting from a reliability perspective. There's a really interesting thing, which is that ACME, the protocol, was designed so that finalize API can be asynchronous. We can return, and we can go off and do this issuance in the background. But because Let's Encrypt originally started by having the certificate ready as soon as the finalize call returns, we found that a lot of clients rely on that fact, and even though you're supposed to poll the order status to find out if the certificate's ready before you fetch the cert, a lot of clients, if the order is in the pending state still, when finalize returns, throw up their hands and give up. So our attempts at actually making that asynchronous have been met with client intolerance, which is a little bit unfortunate because, as I said, the CT issuance process the CT submission process happens in that finalize call, which is this outgoing network request, which could take a variable amount of time. So this is an unfortunate case of Hiram's law of our observed behavior, even though it wasn't in our API contract, eventually being something we're stuck with. And because of the very large volume of clients we have across all sorts of different client implementations, it does mean that we're at least a little bit stuck with that, and we'll continue to hammer and try to make ACME clients happier with that. But for now, we're sort of stuck with this synchronous finalization. And so really what this is thinking about for us is dependency risks. Inside of our CA, we have things that we control. We have these HSMs doing the signing. We have data stores that are storing all of the orders and everything internally. We have these outgoing requests for validation over the internet, which is, has all the exciting internet things of variable traffic and that. But, there are things either we control, the people who are requesting certificates from us control, or otherwise have some sort of contractual relationship with. And so CT is unique in that perspective, in that we don't really have as much control over that. And so we have to manage that risk. Because ultimately, if the CT logs are falling over, they're misbehaving, they're doing something, that's in many ways the biggest outage risk to Let's Encrypt. Not compliance risk, not security risk, really just an outage risk. So we want to make sure that the logs don't fall down. So we do a number of things to manage that risk. The first, most obvious thing, we run our own logs. If we run our own logs, if they go down, rather than sitting being sad that my CA is down, I can go directly handle the fact that the log is down. And as I mentioned in the Q&A, one of our logs currently is down, though fortunately it's just a test log. And we can run multiple logs so that if one Amazon region goes down, we can keep issuing. This is a common strategy. If we look at who the biggest issuers are by number of certs, and we look at who is running CT logs, some of these big issuers are also CT operators, so this is a pretty common strategy. I've included Google. They get a gold star, even though there's some sort of separation between Trust Fabric and Chrome and Google Cloud Trust Services, which I'm not going to attempt to explain. I'm sure some Googlers in the audience can explain that organizational difference to you if you really, really want to know. Maybe we can convince some of these other large bars to run CT logs as well. The next, big thing on our set of things we do to manage CT risk is don't trust the logs. We don't assume that logs are up. We don't assume that logs are returning us well-formed SCTs, and we don't assume that logs are going to hit their MMD because we know that that's a failure mode that they could have. So we need to be careful. And this is something that's bitten other CAs. I think there's many ways that you could, incorporate a cert into the wrong log shard that I think one CA was bitten by. They could have malformed SCTs returned. They could have outages related to assuming that particular sets of logs are up or not, or that particular logs even exist and they're still accepting writes. And because they will eventually break your heart. They are these outside components to your ecosystem, and you need to defend against them in a, not necessarily fully adversarial, but we need to make sure that we're not treating CT logs as trusted third parties for a CA's perspective. The next really big thing that's important for us for managing our uptime is curating the logs and watching those logs for problems. I think we have pretty good monitoring of all of the logs that we're using to, keep on top of them having problems. Reading CT policy mailing lists in the Transparency.dev Slack to get an eye on what log operators are doing. I think one thing that we often do, for example, is if we see it looks like a log might be struggling, we just sort of pull our submission from that log because certainly for us as one of the largest submitters, as a CA, I think having our certs disappear from a log could probably help that log operator if they're having risks of MMD merging delays or anything like that. So it's important that we really curate that. We also, talk to some of these log operators to make sure that they can handle our volume. I think there's a couple log operators that we currently don't submit to because they were having trouble, and we just wanted to make sure we're not overwhelming them to keep the ecosystem healthier as a whole. And so, yeah, we got to curate our lovely collection of logs for submission. And finally, the biggest thing we want to keep in mind is that we don't want to crush the ecosystem. We talked a bunch of the MMD delays right now are caused by one particular client that's cross-pollinating between logs that doesn't have any sort of back-off logic and that is sort of continually running into rate limits. And I want to let them be the problematic client and not us. So we want to, be aware of our fire hose of submissions and try not to take the whole ecosystem down. I think the naive solution for many CAs to submit to logs is just to fire a whole bunch and hope that you get some SCTs back, which we sort of very deliberately don't do. This shotgun approach, as some people call it. So I want to talk a little bit more about actually what our submission algorithm is and how we decide what logs to submit to and how that helps us keep the CT ecosystem as healthy as we can. The naive algorithm I said would be just to submit all the logs, wait for them to return some SCTs, and incorporate those SCTs. We take a little bit of a twist on this, which is we figure out what the set of eligible logs for assert is, filtering by their status and their temporal interval. We pick 2 of those logs and submit to them. Now, as I said, we don't want to trust any 2 logs, so we wait a little bit. Currently are configured to 2 seconds, but that's a value that we could tweak. And if we haven't gotten back 2 SCTs yet, we submit to a 3rd log. If we still don't get assert back, we submit to a 4th log, and so on until we have a set of compliant SCTs. So it's sort of like the shotgun algorithm, but with head starts for different logs over time. So just as a worked example of what that looks like in our software, we submit to 1 log and log 2, and after that 2-second delay, we submit to a 3rd log. And we're now waiting for 3 logs. If we still don't have a delay, we wait for a 4th log, we submit to it, and so on until we're submitting to n logs in parallel. And eventually, in this case, log 3 returns with the first SCT, and log 2 returns with another one. Now we have this pair of SCTs, and we can cancel the submissions for the other logs. Log 4 in this case returned an error even before we got the 2. So we tried a couple submissions. We got back 2 SCTs, which is what's required to incorporate in that final certificate. Now, most of the time, it's not that complicated. We just submit to 2 logs. We get back SCTs pretty quickly, and we don't even need to try to start submitting to a 3rd. And in the happy case, this is good because it means that we sort of did the minimal amount of work for the whole ecosystem to not bother more than 2 logs with a single submission. There's actually some improvements we should make. For example, in the worked example, I showed that I think it was log 3 returned an error. We didn't start another submission at that time. We probably should because we're sort of waiting for nothing at that point. We just kind of start submission to 2 logs and then check if they form a compliant set of SCTs. This is more important with the static CT transition and the current rule that we have 16962 log. Unfortunately, it's quite challenging to check before you submit if the set of SCTs will form a compliant set, because we could submit to 2 logs, and then the 3rd log, we don't know which of the first 2 might return first, so it gets basically into a constraint-solving problem, and then maybe those first 2 logs will return errors, and we need to submit to a 4th, and then that check that we did for the 3rd log isn't relevant because it's actually the 3rd and the 4th that'll return, so it's not something that we have today, but we would really like to. And finally, the other improvement that's on my list of things we really should do is better automatic health checking and back off. I mentioned that we have to curate our logs, and that's a lot of monitoring the log status and metrics and CT policy. And we think that's something that whenever there's something that human operators have to do, it's much better solved with automation. So we'd like to add more of that. We don't have it today, though, which is a little unfortunate, but keeps us on our toes as we watch everyone's logs. There's a whole nother set of submissions which don't follow this algorithm at all, which is what we call informational submission. Right now, we submit pre-certs as well as the final certs informationally to logs. This is what we do for testing logs. For example, the static CT logs, we do informational submission to them to make sure that they can handle our load before they're usable and we can start getting real SCTs, as well as final certificates, which we want to appear in logs, even though they're not required by our operation, just to ensure that they're logged and so that Andrew can email us when we issue incorrect pre-cert and final cert certificates. For informational submission, we do something much simpler. We just asynchronously submit all of them to a small set of logs that we know are, quote, good. And if they fail, they fail. It's no big deal if we lose one or two here and there, especially because they'll eventually end up in logs from any number of other sources as well. We also need to test all of this infrastructure. In my worked example, I showed we had a bunch of interesting cases of logs taking too long or returning an error. But most of the time we don't hit those cases. We just successfully submit. So we want to make sure that our code continues to stay robust to all of the different failure cases. So we actually have a deliberately bad CT log called CT test serve, which is configured to return a number of errors on some percentage. So in the Let's Encrypt staging environment, you'll get back SCTs from this CT test serve logs, which aren't even really a full log. It's just the submission endpoints. They don't bother persisting anything. Because it is our staging test environment, we can be fairly confident that those are not going to be too much of a problem. This is in the Boulder, the software that powers our CA's source code. So we don't have to do too much extra maintenance on it, and we can use it in our unit tests and everything to really make sure that we're staying robust. This is something that definitely, if other CAs are interested in collaborating on our deliberately bad CT log that ruins your ice cream, we can add lots of different problems there to make sure everyone's testing and being robust. And that brings me to really what are some collaboration opportunities here, and why I'm at this is that I would love to share more code in general here. In particular, the submission code is something that we've spent a number of pull request cycles tweaking and making more robust, and we actually think it's still not quite there yet. And so if we're not quite there yet, I suspect other CAs probably have similar problems, and I would love to work with other CAs on sharing that. We recently had a chat with another CA who was interested in that, which sort of inspired this whole thing. The client itself is mostly Go, wrapping the certificate transparency Go library to handle the actual submission. Unfortunately, it's rather integrated into our CA software today, and would be challenging to pull out. It has a bunch of our internal RPC mechanisms and stuff stuck into it. But maybe we could take some of these ideas and rewrite it in the upstream certificate transparency Go library or somewhere else. And I would love to hear from others if that's something you want to work on, or how we can share things. And I think this is the kind of thing where the benefits to log operators really are that we can hopefully improve the ecosystem as a whole. One of the big things about not doing shotgun submission is that with shotgun, you submit to every log all at once, which means that if you add more log operators to the ecosystem, it doesn't really help anyone. But with our approach of submitting to as few logs as possible, that means that every time you add another log or another log shard, the actual load on each individual log goes down just that little bit. And we think that really is a pretty big difference in terms of ensuring that the ecosystem stays healthy, because adding more log operators means that the next log operator after that has to do even less work. So I think that's has an ecosystem benefit for everyone. If you want to stay in touch, I've got some links here. Let's Encrypt has a community forum where you're always welcome to reach us, ask for help. And I've got some links here for staying in touch with myself. All right, Q&A time.
Questions? Yeah.
Hello, thank you for the talk. Does the software prioritize the Let's Encrypt logs in any specific way, or are they just logs amongst the other ones?
Yeah, no, we don't prioritize our own logs, except for the thing I mentioned about informational submission. In that case, we just submit to Google, Filippo, and our own logs. It's just 3 operators rather than the full ecosystem, mostly because we sort of know that they can handle our write traffic. But the software itself has no hard coding except for the configuration about what logs we submit to. One of the other improvements I didn't list as a potential improvement is we would be interested in having some sort of weighted submission, but we haven't done that today.
How do you handle multiple logs from a single operator with that whole algorithm there?
Right. So we don't have any real special handling other than I sort of said we wait for a compliant set of SCTs. So the compliant set check is checking that one, we have no more than one static CT log, and two, that like SCTs are from different operators. So it is possible in sort of the degenerate case with our current implementation that we submit to 2 logs from the same operator. We get back 2 SCTs and we're like, oh, whoops, that was a mistake, and we have to submit to a 3rd log. Because the sort of ratio of logs per operator and number of operators today, that sort of just like statistically doesn't happen very much, but it is I would call it a bug in our current implementation. But this goes back to the sort of it being slightly hard to predict ahead of time, because if I submit to 2 logs from the same operator, I don't know which one of those I'll get a SCT back from first. So we could probably do a little bit better prioritization to try to do that, but today, yeah, it doesn't handle it in the optimal way.
Hey, so I was curious how many eligible logs there usually are that you can submit to, excluding ones that you run yourself and ones that you've disqualified. And I'm curious how you feel about that number as well.
I don't have the numbers off the top of my head. I think it's sort of on the order of like 10 shards, right? Because there's sort of like 5-ish operators, some of which have 2 or 3 logs running at a time. So I think it's probably about 10, but I haven't actually looked off the top of my head. In terms of how I feel about it, I think that's actually, maybe just on a little bit, not quite enough, but close. I'd feel better if there was another log operator or 2. And actually with the recent static CT log support, we have got a couple extra log operators, which I think once those are in the usable state in the log programs, certainly I'll be happy with roughly the number of log operators.
Thank you. Would you consider, especially with static CT, to check the inclusion of the SCTs that you return, or would that add too much latency?
Oh yeah, that's something we're not doing today. We're not checking inclusion, at least synchronously. We have a number of what I call data pipeline improvements planned for next year that we're doing, and one of the things we do want to do is actually check inclusion. I think that goes back to also better automatic health checking. We would like to, if we see a log start to not have inclusion done in a timely fashion, automatically stop submission to that log, because they're probably suffering on MMDs or something, but we just haven't written that code yet. Both from the having that health check hook in our code, as well as having something monitoring for inclusion. Just a to-do. We got lots of to-dos.
Hi. So on that note, Apple has recently published a proposal for a log endpoint where you can check the status of the log automatically. We really think that would help both CA operators and the CT log programs. So please, all of you, take a look at that proposal on the CT policy list.
Yes. Yeah, and actually that's something where, we talked about curating. I think one of the things in that proposal is having a list of sort of upcoming changes. So one of our first priorities is going to be making sure that if a log operator has announced that they're going to go read-only or make some changes to their logs, we can automatically pull it out of our curated set. So definitely excited about that, though I have many technical nits on the proposal as written, but that's because it's a proposal and not a proposed thing. So I actually spent my flight to this conference writing a bunch of code to interact with the new proposal, so definitely looking forward to it. Thank you.
Any more? No? Well, in that case, let's thank Matthew again.
All right, thank you.
And I will invite Mustafa up, who's going to talk to us about how Chrome monitors CT logs.
So, hello everyone. My name is Mustafa. I'm a software engineer in the Chrome security team, and today I'm going to talk about how Chrome monitors CT logs. So, when I say Chrome here, I mean obviously the Chrome team, not the Chrome browser, which is not the Chrome client. So I don't have a slide for this, but I will briefly talk about what it needs, what a log operator needs for their log to be included in Chrome. They submit a proposal to us through our bug tracker, and then there's a 70-day submission waiting period for the log to pass their initial compliance. And if we detect no issues with the log through that 70-day period, we qualify the log, and then we, after another 30 days, I think, we make the log usable in Chrome. So what it means for a log to be monitored is basically we are looking for certain adherence to our log policy. And quick recap of Chrome's CT log policy is there's basically three things we are looking for. First of all is we want 99% availability on all of the endpoints of a log. The endpoints must be healthy, operational, and then they also must be public and not serving only to Google. We want this applies to both to RFC 6962 logs and also to static CT API logs. Even though they don't have the same endpoints, the checks that we do are mainly the same for both specs, both log specs. We want obviously 100% correctness. The log contents, some of these checks are basically the log contents must be consistent. The log must not violate any the MMDs and should serve valid proofs, for example. And we also want that extra bit of communication from the log operator. We want the log operators to extensively use the CT policy mailing list. We would like to see incident reports and any scheduled maintenance or downtime to be announced in CT policy list. And so we have a compliance monitor called Monolog. It's the internal name of the monitor. It's an evolution of a V1 version of the same of the compliance monitor, and it has more fine-grained checks over the V1 monitor. It has near real-time checks near real-time and periodic checks for availability, cert inclusion, and tree consistency, among with some other things. And we publish availability numbers for each endpoint, for each log daily, computed by all these checks. So quick word on incident handling. We have a Chrome security engineer rotation. I think we have 4 or 5 people in the rotation as of today. And our goal is to respond to any incidents within 24 hours. And this response basically means, I will talk about it later in the next slide, but it means investigating whether the incident is actually a real incident and then reach out to the log operator. We do weekly triage of open incidents. This is the open incidents are mainly availability issues. So certain logs can go down below 99% availability and just stay there for some time. So we would like to understand the trend over time, whether the availability is going up, whether it's going down, or whether it's staying flat. So it doesn't mean like if the availability of a log goes below 99%, we immediately distrust it. And also the incidents can come from other sources such as CT auditing. So incident response, as I mentioned, we have an incident commander that starts the initial investigation of an incident filed by Monolog. We first check for log correctness and availability, whether we are computing those correctly on our end. And then if we determine that there is an actual incident here, we escalate and we discuss with the broader team what the next step should be. And the incident commander may eventually reach out to the log operator to ask them to provide some initial response on CT policy and talk about next steps. Unfortunately, we may eventually need to retire the log, as Andrew said, that happens. And I think this year has been particularly harsh on logs. We do check the potential impact of removal before we do actually take action on the log. So we want to understand whether there's any widespread impact that will break the web in general. And so I just want to say thank you for all of the log operators we have today. I think there was a version of this slide from last year, and we had only 6 operators. And now we have GeoMice and IP Engine networks here listed. And I think all of their logs are static CT-API logs. And I think 1/3 of the logs today in Chrome's list, Chrome's trusted logs list, are actually static CT-API. So, and all of the, as I mentioned, all of the new logs are actually static CT-API. So I think there's critical mass on the static CT-API ecosystem now. And I think that's all I have.
Amazing. Thank you very much. Do we have questions about how Chrome is monitoring your logs?
Thanks for the talk. It was really interesting. Can you say any more about the SCT auditing and the kind of incidents that you see reported through that pipeline?
So we are actually seeing some incidents reported as of today, I think. Some SCTs are this kind of not an actual incident, but a result of some of the migrations that has happened through, over the pipeline within the last few weeks. But basically, we are seeing SCTs missing from the SCT auditing pipeline. Basically checks whether an SCT has actually previously been seen and whether it's included within the MMD. And so I'm not sure if we actually taken any action on anything that came from the SCT auditing, because Monolog eventually handles those as well. They actually appear from other channels. So, but yeah, it's one of the channels basically. We don't take action on SCT auditing only.
Yeah. Well, okay. Sorry, I have to dig into the SCT auditing thing for a moment. If you're interested in SCT auditing, there is a public design doc that you can find online that then you can read all about how it works. Short answer is that Chrome clients upload some SCTs they see to the server, and then we can check offline. My question actually is, Monolog sounds cool. I don't think Chrome's the original designer of that. Do you know who originally came up with the design of Monolog?
I think I know, and Kat is, I think, the original designer. And I wanted to actually show a slide here which showed the original names of the checks. And I think one of them was the ladyship of the getter of entries or something like that. But yeah, there was some Lord of the Rings references, I think. So yeah.
I actually can't take credit for that naming. That was Paul Hadfield when he was on the Trust Fabric team. But yes, thank you for that.
Hey, is Monolog available for anyone to run? So, for example, could we get the availability statistics from a different vantage point with that software?
No, unfortunately, it's not open source, but the available numbers that are eventually calculated are public, yeah. And I think the CT policy list has a link in one of the emails.
Any more? That's quite loud, isn't it? Sorry. All right, well, in that case, let's thank Mustafa again. And next up, what I'm right next to the speaker, it sounds weird. And next up it's Bhushan, is that how you pronounce that? I don't want to butcher your name, who's going to be talking to us about monitoring brand logos with certificate transparency. So a round of applause for Bhushan as he comes up.
So yeah, hello all. Myself Bhushan Lokhande. Little bit about myself. So I'm like a senior engineer and product owner at Redshift, working on certificates and hardenized product. Previously, I worked on secure element trust provisioning at NXP Semiconductors, and I was also a primary developer for SSL Labs. during my time at Qualys. So yeah, let's jump into the topic. So on agenda, we first take a look into what is BIMI and how it works. Then email clients and certifying authorities that support BIMI, and then some insights from BIMI certificate transparency monitoring. So yeah, what is BIMI? So BIMI stands for Brand Indicators for Message Identification. It is an email standard that enables organizations to display their brand logo, verified brand logo, next to every email they send. It requires strong DMARC enforcement with 100% reject or quarantine policy. So DMARC is built on top of SPF and DKIM. And yeah, and this is how a brand logo will be displayed on email clients. I have examples from Gmail. So on the left side, I have a VMC type of BIMI certificate. So for verified mark certificate, clients would show a brand logo along with blue check mark. So yeah, so every email you get from OpenAI, you see a brand logo as well as blue check mark. So that's like a visual assurance of sender authentication. On the right side, I have a CMC type of certificate. So for common mark certificate, clients would only show a brand logo, as in like, yeah, Perplexity example. Then without BIMI setup, it's usual no logo as well as no blue check mark. So as I have here, Anthropic example. Then how does BIMI certificate look, or what is different comparing with standard website web PKI certificates? So in case of BIMI, we have in the subject mark type. So on the left, I have VMC example. So this one is with mark type registered mark. So in this case, you have in the subject trademark office, trademark country, and trademark identifier where the logo is identified, validated. In case of CMC, this is less stricter validation. I have this one with mark type prior use mark. So this is based on continuous use of brand logo on a website. For at least 12 months. So that's how the validation works. And in the subject, you have then a prior use mark source URL. So where the logo has been validated. That's the case for CMC. Along with that, in certificate policies, you have certificate mark policy identifier, and then extended key usage indicating BIMI usage. And the last one, the important one, you have in the logo type extension, full logo SVG embedded into the certificate in TinyPS base64 encoded format. So the whole logo is there in the certificate. VMC versus CMC mark types. So in VMC, we have registered mark, which is validated against trademark office, whereas government mark is validated against government bodies. For CMC, we have prior use mark, which is based on the prior use of logo on the website, and modified registered mark. This is like a modified variant of your officially trademark logo. So if you have, in that case, you get a CMC certificate. This is a snapshot I have from Redshift free BIMI checker. And here, once your DMARC strong enforcement is validated, then the BIMI DNS-TXT record is checked. In that, you have this A tag, which points to a VMC or a CMC certificate. That certificate is fetched by clients and then trust validated, and then logo is extracted. And on a successful validation, that logo will get displayed on your client. So these are the email clients that supports BIMI. So the major players like Google, Apple, and Yahoo already supports BIMI. Some are in progress or considering BIMI, and Microsoft is yet to jump in. on certifying authorities side, they are called mark verifying authorities in BIMI ecosystem. And we currently have DigiCert, Global Sign, and SSL.com, the active issuers in the ecosystem. We have only one CT log operator currently active. So we have this DigiCert Gorgon CT log. And from monitoring insights, so DigiCert Gorgon currently has 26,000 plus entries right now. And analyzing non-expired pre-certificates, this is how the CA distribution looks like. So DigiCert is the major issuer, and others are following up. And taking a look at VMC versus CMC distribution, we have majority of certificates issued are VMC. Then some use cases of this CT data. So it exposes a new transparency data set of public data set of verified logos and trademark information and brands. Then standard monitoring and auditing CA compliance use cases. Along with that, also some interesting use cases like detecting logo misuse or brand impersonation, finding lookalikes, detecting mismatch between a logo and a company or the organization name. So these are like for few examples. For instance, we have it in our Redshift brand trust product. Some insights from analyzing those entries. So the first one is example where I found one instance of entry where this mark certificate general policy identifier was missing. So this is like a mandatory identifier needs to be there. So I've found one instance of that. So that's like a policy violation. Second, I found one instance of a prior use mark certificate that doesn't have a prior use mark source URL where it was like validated. Then few instances of malformed SVG inside the certificate, and then a bunch of other cases around mandatory elements like title or version, base profile missing, or forbidden elements being present in the certificate. So a bunch of these cases. And the last one is an example of exceeding the BIMI max size policy limit. So few instances of that as well. So I uploaded like a full list on GIST with all those instances. Taking a look at the policy violation example that I mentioned. So on the left one, this is the one, this is the certificate that's missing the mark certificate general policy identifier. On the right side, this one is still valid certificate. This one is using, as you see, prior use mark source URL is missing for a prior use mark certificate. These are the few examples of SVG title not matching company name. So BIMI policy recommends that title must be included that reflects a company name. So in that embedded SVG logo, there is a title element which should reflect company name. There is no strict requirement to have it exact match, but it should reflect the company name. And I have some examples where like a second one being like a random SVG title, and the first one is like not matching or reflecting the company name. This last one I have, this one is like missing bunch of required elements from that embedded SVG. So like base profile or version or the title element which is mandatory, that's missing. So this is one example. And yes, so this is how the certificate transparency is helping BIMI and email security ecosystem. And looking forward to questions and discussion.
Thanks for the talk. You found a number of issues that to me look like the certificate itself was misissued. So there's really some fault here was with the CA that provided
Yeah.
that certificate. Is there any are there any repercussions now that you've detected these issues for the CAs involved or for the end entities that got the certificates?
Yeah. So the ecosystem is still evolving, and I will try to get in touch with them, the CAs, and they should like rectify. And the one example I gave, which is still valid certificate, that should be revoked. And I see that the newer ones are following all the policy recommendation. So policy is also evolving, and yeah, ecosystem is expected to evolve like we have for the web PKI ecosystem.
Yeah, thanks for the talk. So are any of the email providers checking SCTs in the certificates?
As far as I read, yes, they are checking the SCTs. So the inclusion in the log is like, yeah, recommended in BIMI policy.
Well, one of the issues you brought up is that the title of the SVG doesn't reflect the company name. But how did you find these? Did you just like check 6,000 certificates manually?
Not manually. So I ran some automated analysis. So I also tried to find if there are some security violations, so like script elements present in SVG. So SVG can have a lot of not so good things. And this is how, so I extracted organization name from subject and then title from the embedded SVG and try to match it like a vague match, because it need not be the exact match with case and everything. But like, yeah, these examples were output.
So you talked about like the potential for using transparency logs to identify brand misuse, but I'm curious what the sort of policy is around verifying like CMC certificates to make sure that you're not issuing something to someone for a brand that they don't actually own just because they like made a website that happens to have that logo on it for a few months.
For at least 12 months.
Yeah.
Yeah. So that's like a less strict validation, and that's how the policy states that if you use a brand logo for at least continuous usage of brand logo for 12 months on a website, and that can be like validated on Web Archive. If that's the case, you get the certificate. So yeah, so certifying authorities can do furthermore stricter checks, but that's the like yeah. It's more for increasing the adoption of BIMI, because getting a trademark office validated certificate takes time. So I think once ecosystem evolves, there may be stricter validation checks. So as I mentioned, we have currently somewhere around 6,000 plus non-expired pre-certificates. So like, yeah, that's the number of kind of organizations. So the usage is that small, yeah.
Have you ever found a logo that should not be there, like somebody who claimed that they own a logo and used it, but it was the wrong company?
I haven't found that one. Yeah. So like in our brand trust product, it works more on the AI to analyze that logo, and yeah, that needs more analysis and trying to put some context and figure out if like something wrong is going on.
Is it working now? Yeah. What prevents a BMCA from just not putting stuff on the log? So basically, what's the analogous of the Web PKI CT enforcement policy in this ecosystem?
Yeah, for this one, I need to get back to you and further check this. Yeah.
You said they were email providers were checking SCTs.
Yeah. yeah, let's have a discussion, and yeah, if I understand the question correctly, yeah.
I'm actually kind of intrigued. Why did you choose to go for vector graphics as the only option instead of using raster graphics?
Could you please repeat? So what's?
Yes, you are embedding an SVG file that's normally used for vectorial graphics instead of, for example, a PNG file that would have raster graphics. What is the reason why you choose to go specifically for vector graphic logos, especially knowing that not all of the companies necessarily have a vector graphic version of their logo?
Yeah, again, I think this is defined by the BIMI working group. So yeah, it's more a question for them. Yeah.
Well, with that, let's say thank you again. And we're going to introduce Joe. Joe, who's going to talk to us about things going bad.
Ooh, it's like trip and fall and break my face in front of everyone. Yeah, exactly. All right. Thank you all. So I'm going to talk about when things go bad. I renamed it at the last moment to when logs go bad, which is totally unfair, and I'm maligning log lists, but it's mostly because I wanted to use this image, which made me laugh, which is a bad log list. Sort of. So that's all that is. So who am I? I'm an engineering manager on Chrome's network security team, which means I do no real work, but I like to talk about a lot of things. So let me tell a quick story for you. Way back on June 18th, we sent this email out saying, hey, we've qualified some new logs for inclusion in Chrome's CT log list. And, this is an utterly routine event for us, so much so that we don't send these emails anymore because they're not actually actionable for anybody. But so that was June 18th. And then the following Saturday, a couple days later, I got a text message from my product manager being like, hey, you should know about this GitHub issue. And also it was flagged to me on the Transparency.dev Slack, so thanks for that, telling me that a whole bunch of Android apps had broken, impacting tens of millions of users. And for most of these apps, as soon as you opened the app, it would immediately crash and return back to your home screen, which is not awesome and not at all expected because I'm updating Chrome's log list for Chrome. So if anything, I'm expecting to break Chrome. So let's take a step back and provide a little bit of background. Chrome publishes a log list in JSON format, which represents all the logs that Chrome recognizes for complying with our CT policy. This is mostly listed for certificate submitters, like Matthew earlier talking about Let's Encrypt, and how they choose what logs to submit to, so that you can assemble the set of SCTs you need so that things work in Chrome. It's also published so that monitors, people like Andrew, and those looking for misissued certificates know where they can find logs and go from there. It's pointedly not for the use of other user agents hoping to enforce CT. In my opinion, well-behaved user agents publish their own log lists. Apple, for instance, publishes their own log list. It is possible to rely on other user agents' log lists. Some folks, such as Android and Firefox and several others, sit downstream from Chrome's log list, but they've worked with us to make sure that they can do so safely. If you don't do that, you sort of do so at your own risk, as we'll see in this talk. So, what did we do? We recently made a change to our log list schema in order to support static CT API, and we announced that schema in October of 2024. But we announced the schema, and then nothing changed day to day for quite some time. Enter the AppMatis Certificate Transparency Library, which is an open source library available on GitHub, and it lets you enforce CT on your Android app. And this filled a really important niche for the community because up until Android 16, which just came out, there was no native support for CT enforcement on Android if you weren't running in a web browser in Chrome or similar. This library, however, is maintained, as all good open source projects are, by one person doing their best in their free time. And that's a tough place to be, but that means that it's quite difficult for them to maintain their own CT log list, and so they piggyback on Chrome. And in particular, every client that uses this library fetches Chrome's log list every time you open the app, which is, as a fun fact, hundreds of thousands of QPS continuously on Chrome's servers. The library also has very strict schema expectations and enforcement, and if anything changes in the log list that it doesn't expect, it will crash. So, predictably, it crashed. So if we go and look at that GitHub issue, we can see that someone pointed out that there was this empty logs array, and that the library was not expecting an empty logs array. And that's because that logs array only lists 6962 logs, and our big schema change was to add this tiled log array so that log operators could have tiled logs, i.e. static CT API logs as well. So how did we fix this? Within a couple hours of the incident, we rolled out a fake log, a 6962 log, for this new log operator. By the way, this new log operator is GeoMice, aka Filippo, so we can all blame Filippo for this whole incident. And so now we have this bogus placeholder log included in our log list. And actually, we've maintained this over time. So there's now IPNG is also a static CT API only operator. And they also get their own bogus log now. And that's a fine Band-Aid. But I'm getting ahead of myself. For those who attended CATS in 2023, you may remember a different lightning talk by Roger talking about a library that crashed when there was a schema change in Chrome's log list. And indeed, it was exactly the same library. So obviously, we did not adequately address the issue at the time. So this talk is really about what we're doing about it now. So both of these sets of breakages came down to schema changes that were unexpected by downstream consumers of the log list. That's more or less unavoidable from our perspective. In this case, for instance, and last time, we announced the schema change long in advance, and we can't maintain a list of every single library that's using our log list because they're not us, right? Like, it happens to be that this library is the most was the offender in these two cases, but it's not the only one. So we're taking steps to be more active in shaking Chrome free of these dependencies, because when this breakage happens, Google gets blamed, which sucks for me as someone who works for Google. But also, while I'm confident that we will always do the right thing when the security of the internet is at risk, so if we have to push a change to the log list urgently, we will do the right thing. But there's a whole bunch of sort of squishy bits where if you have a log list that, like, we have a change that needs to happen, but it doesn't really need to happen now, then suddenly a bunch of very important people at very big companies whose apps aren't working get on the phone and call my boss, and my boss's boss, and my boss's 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 boss, etc. And sooner or later, it gets very hard for us to do any of the changes that we need to make. So it's really important that we don't have those dependencies. So the very first thing we did was we published an acceptable use policy. This is great, not enough. For the library in particular, huge thank you to the folks in the community who made the case on the bug that maybe this particular library shouldn't be doing this. I also chimed in on that same bug saying, hey, please don't do this. I also actually, in this case, reached out to the person behind this library and said, hey, can we sponsor you to make things better? Unfortunately, that didn't work out. So now we're going to be looking to take a more active approach at shaking free of those dependencies. Starting next year, Android apps that use this library and other libraries like it, there are a couple in our set, will start receiving warnings when they try to publish updates in the Google Play Store. And the reason we're doing that is we're trying to say, hey, you really need to migrate off of this. We're also going to do direct outreach to some major apps. And then we're going to start breaking them again. Except we're going to do it on our timeline instead of, accidentally when it happens. As I said, hundreds of thousands of requests per second. Legitimate requests for those endpoints is like 0.1 QPS, maybe. That's probably quite high. So it's not hard to identify the unauthorized use cases of these endpoints. So yeah, my big recommendation here is if you're an Android app developer, please, please, please don't rely on third-party CT enforcement. I know there was a gap in CT enforcement opportunities there. Now it's fixed in Android. Use that going forward. If you're looking to develop a TLS client that wants to enforce CT, ask yourself if you can really commit to running a proper CT log program. If you can't and you want to rely on us, come talk to us. Don't just do it. There are ways to do this safely. And if you don't, we'll come and try to break you, which is not any fun for anyone. So that's all I got in my little lightning talk. Questions?
So question on the Play Store where you would block some updates. Have you decided how that's going to be done? Like, is that actually looking at the code of the app itself? Or are you going by user agents that you're seeing that are pulling the log lists? Just wondering how.
So we can't go by user agent directly for this purpose anyway, because most of the user agents are sort of generic, clearly coming from Android, which is a pretty good indication, but not a perfect one. Google maintains a great, like, creepy eye in the sky, don't tell anyone I said that, database of all the apps that are published in Play. Yeah, it's fine. It shouldn't be surprising to you that we can look at what apps are submitted to our App Store. So we're going to go off of that. That's not a perfect data set, so we're going to do some additional analysis on top of that, but we'll do the best we can. There is an inherent risk that we will miss some apps, but that's just the fact of the matter. I can't fix that.
How are you planning to break these CT checking libraries?
Well, so a number of these libraries, as I said, have very strict schema enforcement. I can publish whatever I want at that URL. So, who knows? And we can also differentially serve different content based on things like user agent or other characteristics. So we have a couple of options that we're exploring. For the record, I'm not excited about breaking these apps. I take no joy in this. I just really, really, really want to make sure that when Chrome needs to be able to push an update to our log list, that we can do that without, escalations to my senior vice president from the CEO of some major corporation. Sort of deal.
So we currently have the V3 of this schema based on needing to evolve it. Have you considered going to a V4 and letting the V3 files rot in place?
That's kind of the situation we're at for V2 right now. Is some of these apps are still using the V2 log list, and indeed, I haven't. It is on our to-do list to bring down the V2 log list, but I'm not keen to do that until I have an answer for all of the apps that are using the V3 URL, because I don't want all of these apps to just migrate and make my new problem bigger. That is an option. It's kind of a pain in the ass to keep bumping the URL around for all the legitimate consumers. And the last time we did that, all the apps just migrated. So it didn't solve our problem. It just kicked the can down the road until we have to do some other schema update. So yeah, it's an imperfect solution, but not a terrible one.
Thank you. Do you see a risk if more UAs and other consumers or apps that need a log list start making their own, and if there's more divergence, there might be other causes of breakage due to CA starting to use a new log list, it not being in certain log lists, then stuff breaks. So do we need some other kind of source of a consensus on which log lists are acceptable to use?
It is absolutely a risk to the ecosystem if we have a zillion different programs with subtly different lists. We already experience that right now with divergence between different UAs lists. I know that we in Chrome pay a lot of attention to what those other UAs are doing, and like it's important to us that, for instance, we never do anything that would make it impossible to satisfy Chrome and Apple's policies. Like that would be bad. I'm actually a big fan when folks sit downstream of our list, as long as they're doing it safely, because it helps avoid this problem. But yeah, I think some level of coordination is essential if you're going to run, if you're going to be an active participant in this ecosystem.
Thanks. Just a quick idea. I've noticed Let's Encrypt in their Acme directory objects using a technique where they're just adding some randomly generated JSON objects so that if you're enforcing the JSON schema strictly, well, you're going to know about it pretty quick. Have you considered doing anything like that?
So we have, and I think it's much easier to do, well, as soon as we do anything that starts causing breakage, we're going to hear about it, and so we need to be quite careful when we do that, and so our expectation is it's going to be a manual process for this foreseeable future. Once we've sort of shaken loose what we can, I think adding some sort of automatically generated noise or similar is not a terrible strategy, which we might explore once we're there, but that's sort of further down the road than I can see right now.
Have you considered a CAPTCHA?
A CAPTCHA. So actually, you will hit a CAPTCHA if you hit it enough times from the same IP, but there's a very distributed denial of service attack on these endpoints because it's essentially one request per service. So joking aside, there are things we could do. We have talked about things like, okay, now you need an API key in order to access this log list. That sucks. So I'm not keen on that, but I'm going to do everything I can to shake free of the bad dependencies and keep things as open as possible. And then if that doesn't work, we can look at more aggressive approaches.
We'll make this one the last one.
Is there an easy, good way to do whatever Chrome is doing?
So the most important thing to do if you wanted to sit downstream of us is somebody has to be paying attention and monitoring the changes and making sure that every change, especially schema changes we make, but other changes too, are still safe for your users. And that requires a time commitment. Like you need to be following along on CT policy and that sort of thing, and that's sort of a drag. Otherwise, the big things we ask for are things like you should have a 70-day kill switch, which is built into all well-behaved CT enforcing clients right now, where if you don't get an update from your update service within that time frame, it won't enforce CT anymore, and you shouldn't be directly fetching the log list from us. You should be fetching it to your servers and then pushing it back out to your users, so that if you do detect a problem, you have some way of sending different data to your clients, so that you can see the train coming, but you can't do anything about it, right? Which is the situation that the library is in, for instance. So there's a bunch of little things like that, but it's not actually that hard to do. It just requires you running some infrastructure and staying actively engaged with it, and that's a lot to ask if you're one person with an open source library. Obviously, I'm frustrated at this situation. This library developer is operating in good faith and has worked hard to fill a niche in the community. So I'm not upset at them. I just this is the challenge of the CT ecosystem writ large.
Okay, so let's say thank you to Joe again. Thank you very much. The speaker doesn't like me. So now it's time for lunch. We will come back here, get started again at 2 p.m. A reminder to the speakers for this afternoon's session, which is on operations and new developments, to come back a bit before then to get mic'd up, say 15 minutes. Make sure you're here by 1:45 with the production crew, and they will get your mic sorted. A reminder to everyone that after that session, we have the breakout sessions. So far, I think those boards are blank. So that's going to be a real empty slot at the moment. But no, so if you have ideas, I know there are some people that came with ideas already. So if you can go and start writing them up at some point over lunch, that would be great. Annalie, are you okay to guide people to where lunch will be? Follow Annalie to food. Woo! See you this afternoon. Oh, is that on? Did that work? Hello? 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 Hello, I'm going to go up here again. How are we all? Full? No longer hungry? Some people, I feel weird holding this now for some reason. Earlier it was fine. Some people have expressed disappointment that I didn't make it clear that the soft serve ice cream machine is now up and running. So maybe during the next break, make the most of that. I had some. It's delicious. There are fun flavored syrups and sprinkles. It's everything you could want. Right, so we had a really good morning. I hope everyone enjoyed this morning's talk. We've got some great stuff lined up for this afternoon. Yeah, one thing Rasmus has asked me to mention, because he's sad that no one has actively commented on it yet, is, do you like our transparent podium? Because it's Transparency Days. But yeah, that's all I have to say right now. Like I said, we've got, our next session is operations and new developments. And with that, I will hand over to Roger, who is our first speaker.
Thanks. All right. Hello, everyone. Today I'm going to talk about Android certificate transparency. So you may have already heard about this, like from Joe early before lunch. So I'm Roger. I'm a software engineer from Google, and I work mainly on certificate transparency and transparency log in the Google Trust Fabric team. So today we are going to go through this agenda. So first of all, we are going to have a quick overview on the API level of the Android CT, and we will talk about the policy and log lists. And then next, we will talk about how Android developers can opt into CT, and the technical architecture, challenges, and end with the key takeaways. So here is the overview. So support, it is only support available from Android 16 and API level 36. And for policy, it is aligned with other user agents CT policies like Chrome and Apple. And they got all the same SCT requirements and the same enforcement timeout. So no log list will be no log list is available on device, then we'll just disable the CT enforcement like after 70 days. And then for the log list, it is published as a JSON file on gstatic.com, and it is updated daily. We support RFC 6962 and static CT API logs. And the audience are, of course, the Android connectivity module, which we natively support starting from Android 16, and the CA monitors and the auditors. And so there is a caution here, like just make sure this log list is not being used for CT enforcement in other TRS clients. So the log list format is not stable, and apps are not expected to rely on it to enforce CT on their own. And then here is how we can opt into CT for Android developers. It's actually very, very easy. So we start with the network security configuration. It's important to mention again, like it's only available starting from Android 16. So by default, the enforcement is disabled at the moment, but opt-in by default is definitely on the roadmap. So here is how you can enable it. Like it's simple, just a line of code configuration, then you enable it. So people may ask, how about I want to have different configuration for each domain? yeah, we got that support. So it goes through this evaluation order. So if you got anything like user trust store or some specific root certificates, then the verification will be disabled. So here is an example. It's flexible. Like this example is like for all we would like to enable CT for all domains except Android.com and example.com. So we do it like the previous slide, just enable it. And then for each domain, Android.com, you can choose to disable it. And if you got the user root store enabled for example.com, then the CT enforcement will be disabled. So we'll go into the technical architecture, mainly focus on the CT enforcement using Conscript, which is module on the Android device. So we got the network security config in the app, and we also got the Conscript module, and there is a trust manager in there. So if you use the default trust manager, then it will be using the Conscript implementation for the trust manager. So the trust manager will take the network security configuration, and there is a read-only file system storing the CT log list. Whenever there is SCT verification, then it will read it from the CT log list. And if there is a HTTP request from the app, then it will go through Conscript to finish the SCT verification. So what are the challenges? I would say I was asked 2 questions: how to bootstrap CT securely, how to effectively distribute CT log list to the billions of devices. So we can start with the life of CT log list on the device. So there are 2 different phases. So in the very first phase, onboarding, there is no initial log list on the device. We got our CT service in the connectivity mainline module, which contains the log list URL, which we have already mentioned is a JSON file. And then phase 2 is a regular update that it keeps download every 24 hours since the device boot. And then the CT service would verify the log list against the signature file and with the public key on the device. And the public keys, they are distributed through the software update, not with the other mainline module update. And if the verification is a success, then the log list will be installed to this specific path, which is read-only and secure, and then it will be ready to be consumed by the Conscript module. However, there could be some unexpected scenarios, like if the log list signature is invalid, that you cannot verify the log list, then the log list will not be installed to this path. And if it is outdated, then the CT enforcement will be disabled. So another challenge is the CT policy change. So when there is a change that requires any schema change or enforcement logic change, is challenging to keep billions of devices up to date with these changes without breaking the TLS connection. So we have to, we got 2 modules here, like as we have already mentioned, the connectivity and the Conscript module. The problem is these modules may not be in sync. They may not be updated at the same time. They could be different updates at different time. So let's say for this one, we got compatibility version 1 here. And then after a while, we got compatibility version 2. Then it's possible to have different versions, different log list compatibility versions with different Conscript version as well. So so let's say for app 1, we use we have Conscript version that will read from version 1, and app 2 Conscript version will read from compatibility version 2. So we would just, so when the compatibility version 2 is available, let's say the version 2 log list is available, the V1 log list would become best effort. So there is no guarantee to keep the older version up to date. So after 70 days, the log list, version 1 log list would be outdated, and there will be no more CT enforcement for the app 1. So the key takeaway is to protect users from man-in-the-middle attack and misissue certificates by opting into CT in the network security configuration. Yep, thank you.
Any questions?
Is there like going to be any support for the application to dynamically react or provide its preferences about certificate lists, or sorry, which logs it, or what log requirements it wants?
So the logic is enforced in Conscript module. It's already there. There is no way to configure it at the moment. Yeah.
So you said you have to target API version 36, which I think means, if I understand Android app development correctly, that means developers won't be able to take advantage of this feature until they discontinue support for older Android versions. Is that true? Or is there some way to ship a different version for different Android?
So I actually prepared this question. So there, unfortunately, this is not possible. So we can backport multiple modules like the Conscript module and another one, but not the network security configuration. So the apps will only be able to like enable and disable CT starting from Android 16. I mean, like API level 36. So before that, there's no way for you to configure it. So it's not safe to backport it to the older Android versions.
So opt-in enforcement in Android is awesome. When's it going to happen by default?
This is a very good question. So I don't work for Android, so I can't tell you the exact timeline for that one. But you are very welcome to ask in the Slack or in the Google groups, and I'm pretty sure someone from Android will answer your question.
Roger, is the log list JSON, is that the same file that that Chrome uses, or is it a separate list? And if it's separate, are they kept in sync at all?
So it is on a different path, but the content itself is, I believe, is the same. The schema should be the same. I mean, at the moment, we don't publish any schema file for that log list because, we don't want any other audience to make use of it for TLS enforcement.
Do you enforce CT when updating the log list?
So this is the bootstrap question. Back to the slide. This one. Is it this one? So when you download the log, you have to. Oh, it's gone. So when you download the log, there is a signature that you have to verify, and also there is a public key that's against the public key, which is not distributed on the same gstatic.com, which is on the device. So you have to verify the log list before you install it locally.
So you talked about how apps can adopt it, and so what about network connections that the operating system is making itself, not on behalf of apps?
So for the internal one, I don't have the answer, but I think it's in progress. Yep, the first party adoption is in progress.
Okay, we're going to leave it there with questions because somehow we're already running behind. I take full responsibility. It was because of the transparency podium chat. Okay, give it up for Roger again. And next we have Dennis, who's already there.
There we go. Hi, everybody. So I'm Dennis. I'm at Mozilla, I'm a cryptography engineer. And this is a spare time project called HelioTorrent. And like all good side projects, it's a story of hope, disappointment, and potential success. So the hope. What if you could do static CT and fetch it peer-to-peer? This would potentially save log operators a hell of a lot of bandwidth fees because the read path is extremely expensive for log operators. And like all side projects, you kind of start out hoping it's going to be a fun little side project that you're definitely going to finish and you'll be done by Monday. Disappointment. There's tons of really, really cool peer-to-peer software. So you've got things like IPFS, you've got IRO, you've got DAT. There's like a gazillion different proposals to take BitTorrent and make it mutable and fancy and new. And honestly, none of it works, at least not yet. That's my general read of the ecosystem, is that maybe 2026 will be the year of like great peer-to-peer on the desktop, but we're just not quite there. So what does work? BitTorrent. Good old early 2000s BitTorrent still works. Now, it's got some wrinkles. Obviously, static CT logs change over time. And once you've published a torrent, it's fixed forever. It can't change in classic BitTorrent. It is full of SHA-1, crappy HTTP implementations, and altogether like more C++ than you should be comfortable with in 2025. But it works. There's vibrant communities of people using this all around the world. There's libraries for every major operating system, apart from iOS. There's there's library support, all different kinds of client. And so we fall back to trying to do static CT over BitTorrent. How are we going to do that? Well, we're going to take our log and we're going to carve it up into torrents. So we're going to take a contiguous range of entries and package all those tiles into a specific torrent file. We're going to take all those torrents and put them in a machine-readable feed. So a lot of torrent clients support RSS for automatically consuming torrents. So we have a list of all the different torrent files that we've produced, and we've packaged them up so that torrent clients can ingest them. And then perhaps perversely, we're going to take the log and the torrent clients and the RSS feeds, and we're going to go and serve them over HTTP to torrent clients. Now, that might sound slightly backwards because we're trying to do static CT over BitTorrent, but the advantage of this system is that you can serve all these torrent clients without actually running torrent software yourself. You can use existing kind of HTTP servers, and once you've seeded a few clients, all the different BitTorrent clients will then work peer-to-peer. So although you're helping them, you're not actually directly participating in the BitTorrent swarm. So over more than one weekend, I hacked together some stuff to do this. So the first part of this, like carving the log into torrent files, publishing them in feeds, that's basically just a fancy static site generator written in Python. And then actually serving all of this to clients in a way that kind of works with the idiosyncrasies of existing BitTorrent clients. That's like 1K of lines in Rust using Axon. It's like a quite a nice HTTP server. And we can see a very quick demo of this. So I have a running instance that has a feed. It's got all the different kind of logs in Google's log list today, maybe 4.5 terabytes of data across the different logs. And each one is packaged into a bunch of torrent files. And what we can do is we can take existing kind of off-the-shelf software. So FlexGet is a very popular kind of torrent automation library. It's like widely used. And all we need to tell it about is where to find our RSS feed and where we want to save those files and the torrent client we want to use, in this case, transmission. And we can just go and run FlexGet. So this is not my software. This is just pre-existing software. And it's going to go and grab all those torrent files for us. And it's going to take transmission, and it's just going to feed them straight in once it's finished grabbing them all. Come on, Wi-Fi. There we go. OK, so now I have a torrent client. It's downloading the entire log list over CT. over BitTorrent. So in terms of outputs, there's a public repo that you can go and look at, and it's got all the different Rust and Python bits that I've cobbled together to make this work. There's a running instance you can play with if you just want to go and grab some torrents. It works for all the existing trusted static CT logs. And there's a spec. And when I say spec, this is really more of the how-to manual of not to trip over all the weird bugs in the different torrent clients out there. I tried to test as many as possible. But they all speak HTTP. None of them quite speak HTTP the same, which I think is an artifact at the time. In terms of success, every project, and especially every hobby project, exists on this continuum from draw the rest of the owl to what a beautiful owl. This is kind of right in the middle. I'm pretty happy with what's been drawn. Like the half of the owl on the server side, I think, it works pretty well. I've spent 0 time on actually a torrent client, a CT client that can actually fetch and integrate with BitTorrent. So at the moment, although you can provide all these files to clients, there's no existing CT client that actually makes use of that. That's a separate and interesting job. So if you're generally interested in this, if you think this is cool, if you've got feedback, if you want to know more, come say hi, come talk to me. I'll be around for the next few days. Thank you.
Questions? Not that it's a battle.
One of the big lessons that we learned on the Direct Connect network many years ago is that using different block sizes, like BitTorrent does, is a really bad idea when you might have different copies of the same file that are published under different identifiers. Have you considered on setting a specific block size on your torrent files to ensure that that does not happen and that your torrent files are uniquely identifying a specific type?
Yeah, that's a great question. So I've given a lot of thought to trying to make the torrent files unique for a given log. I've dealt with much of that, but I actually didn't know about the block size variability. So that sounds like a great fix for the spec. So that's great feedback. Thank you.
First, thank you as somebody who pays for. Oh no, sorry. As somebody who pays for bandwidth, otherwise, yes. So the HTTP fetches, are they from a special server or are they directly from the log?
So I'm very frugal on bandwidth. So these are going straight from the log through this Rust proxy. So from the log's perspective, there's only one client out there, which is a normal HTTP client. It's got a user agent that's conformant, follows rate limits, etc. And then however many BitTorrent clients they never talk directly to the log. So it kind of shields it from that impact. The log could cache, the proxy could cache all of the log stuff to completely take the weight from it. I didn't do that because I'm too cheap to pay for the disk storage, but you totally could.
Thank you.
Okay, so how do you carve up the files into torrents and how do you handle partial tiles?
So, answer, don't. So I carve it into roughly, I think, 1 million entries, 4,096 tiles. The data tile, the L0 hash tiles, the L1 hash tiles. Anything higher than that, things like the checkpoint and the issuer, I expect your torrent client to still fetch those over HTTP straight from the log. And that means that 99.9999%, as an exact calculation, of the log's data will be fetched over BitTorrent. And that remaining 0.0001% is a vanishing cost for the log. So it's basically perfect is the enemy of good enough, was my thought.
Yes, here. Very interesting. I was wondering, from what I recall, the superpowers of BitTorrent comes from the underlying technology, which are like DHTs, distributed hash tables.
Yep.
And these are like a way to store little immutable pieces. So the static logs are made of little immutable pieces. Have you looked into skipping the whole legacy BitTorrent ecosystem and trying to implement a distributed log just with a DHT?
Yeah, so my understanding, not explicitly my area, that IRO is kind of the closest thing to this, and it's got a lot of tooling for doing that kind of thing. My perception is that it doesn't really work at scale, is basically the challenge, that when you try and scale this to the level of static CT with those individual entries, then a lot of the software just chokes, unfortunately. I don't know how true that is. I would love to be proven wrong. but my sort of perception was we're not quite there yet. Like IPFS in particular tried to do a lot of kind of commingling of stuff on the DHT, and I think really, really struggled, unfortunately.
Okay, let's thank Dennis again. And now we have Philippe and Roger to talk to us about Tessera, I believe.
Okay. Can you hear me? Yes, does it work? Brilliant. Let's go. So hello, everybody. Today we're going to talk about running production logs safely, hopefully, using Tessera. It's actually quite fun to give this talk after Andrew's talk this morning. We'll try to explain how we try to solve some of these issues that he raised. My name is Philip. I'm an engineer at Google in the Trust Fabric team, working mainly on certificate transparency these days.
And I'm Roger, so I don't have to introduce myself again. So we can go straight to what is Tessera. So there was an introduction talk last year. We are here to present, but this is the work of the entire team and collaboration with great ecosystem participants and some of whom who are in this room. Tessera is a library to build tile-based transparency log, and it is open source. It is GA already. It is written in Go, and the philosophy is simplicity, resilient, and available, flexible but opinionated. So Tessera will always put you on the safe default path, but you can tweak the configuration if you want. And for APIs, write is actually very simple. Just need to append.add to add your data. And then for read, we comply with the C2XP T-log tile spec. C2XP is the community cryptographic specification project. It's open source. It's maintained on GitHub with standardized logs, read API for with file-like structure, especially for the T-log tile spec.
And we know that you all run different type of infrastructure, so it was very important for us to make it such that Tessera can run on as many platforms as we could support. So if you use POSIX and have just regular servers, you can run Tessera. It also works natively on GCP, AWS, using specific products such as GCS and Spanner, or you can just run it yourself with any S3 compliant storage system and a MySQL database. In terms of performance, it can scale quite well from 1 QPS or even less if you want to more than 15K QPS. How far it can go really depends on the infrastructure that you have, but also how much money you're willing to spend because, well, you know, if you use the cloud, for instance, the more QPS you want to serve, sometimes you have to pay more money. It is being used. It is being used in production by Sixstore, and then its CT version, which we call Tesseract, is used in production by our friends at IPNG, and we use it ourselves and staging at Google, and I hear that there are more log operators that have starting to deploy it in production, so that's exciting. It was very important for us to make it reliable, and so as such, you can run multiple servers for a single log if you want. If you want to run only one server, you can as well. If you want to run 0 server, you can use some serverless type of deployment, should work. Actually, we've tried it, and it works. So now that we know what Tessera is, we're going to look at some challenges that are inherent to running transparency logs, CT logs, but also any transparent logs, and we'll see how Tessera tries to address them. The first one is that outages happen, computers go down. So you run your Tessera server, and then it can just go down. If it goes down, it means that you can have some availability issues, indeed. So one of our goals was to make sure that the right endpoints would stay available as much as possible, And that also, you could run multiple servers in one go, which could be either intentional, because you actually want to have 2 servers, or because you configure your system to have only 1 server, but the cloud environment that you work on make it such that at some point you have an update and there are 2 running for like half a second. So Tessera's approach for this is to only use atomic operations. And that means that 2 servers cannot update the log at the same time. It's just not possible. Depending on which backend you use, we have slightly different implementations. So we can say that we have 2 main categories of implementations. The AWS, GCP, and S3 MySQL one, they use databases that manage all these atomic operations. Depending on which backend you use, you'll have a different database. And one thing that we've learned here as well is that you need a database, but you also need something to store your file, which usually depends on S3 compliant storage systems, and they're not all the same. So if you want to use your own, be careful of the guarantees that they give you, because they won't give you all the same guarantees, and your log might not behave in the same way. For POSIX, we can just rely on POSIX atomic operations. There's no central database. Everything happens with a file system. Something which is very important to notice is that this is a reliability feature. The fact that you can run multiple servers is not here for performance. It will impact performance, sometimes for the better. If you have more servers, you should be able to serve more QPS, but that was not the intent, which means that maybe you'll get more juice out of it if you have a beefier VM than having multiple ones.
So another log challenges is like sometimes read and writes, they could impact with each other. So read and writes, they are equally important. Another goal is to ensure read should be as cheap as possible. So with Tessera, reads don't go through the write server. And for AWS and GCP, the writes, they are staged in a different database. They go into Spanner, Aurora. And then for reads, they go to GCS or S3 directly. You don't even need to run a server yourself. And for POSIX, Tessera personality can only serve the write traffic if they want. It could be another server serving only the read APIs.
Another common challenge when running logs is, well, especially if you're CT, you want to run an append-only database, it accepts public submissions, you almost guarantee that somebody is going to abuse it. So you need to be very careful into what you put in your logs for multiple reasons. The first one is that you don't want to host data that you actually don't want to host. And then also just storage. You don't want to pay for things that you don't care about. Tessera's approach for this is that, well, Tessera is a library, so it does not filter the data for you. But because it's a library, you should embed the library in your server, and you should really filter the data in your own server. To figure out what data you need, you should really be careful about your climate model. So that's the model that is going to make it possible for you to really understand the transparency guarantees that you have around your ecosystem. And you should really have one before you design any new ecosystem. And from that, you can know exactly what you need to accept and only what you want to put in your log. So an example for Tesseract, which is the CT server that works with Tessera, is that we will rate limit submissions that are too old, and also we only accept certificates that chain to a very specific set of routes. This is actually mandated by city policy, and it's a good thing. Too many requests. I think it's a problem whenever you run a service on the internet. People can just send requests, and you might become overloaded. And so you should really avoid accepting more requests than you can process. This is actually very interesting with like Andrew's talk earlier, who say that you should really be careful about not incorporating ACTs. You really want to incorporate all the ACTs that you give. And so we have different setups, we say, depending on the implementation. And AWS, GCP, and MySQL use a sequencing database where it's going to dump the data first when it receives it. And then an asynchronous process is going to put it in tiles. What I want to highlight here is that even though there is a database, and we've heard before that it might be tricky to have a central database when you run a CT log, this is very different than what was done before with CT logs, because in that database, we actually commit to the sequence number. We commit to where the data is going to be in the log, and we won't lose this data. It's there, and we know where it's going to be. Eventually, this asynchronous process is going to put things into tile, all the data into the log itself. And so Tessera gives you the ability to push back if you're running too far behind. So whenever it receives a request, it's going to see how many requests are in this sequencing table that haven't been dumped into the log yet. If it's okay, if you're below the threshold, then you can process the request. If it's not below the threshold, then you just reject the request and you cannot write to the log anymore, which is a good way to make sure that the log doesn't get too far behind. That's something that you can configure quite easily with your log. It's an the Tessera option. There's a few of them, and they're all usable in the same way. But overloads could happen for different reasons as well. Somebody could just send the same data over and over and over again repeatedly. You could even read the log itself and feed the last entries back into the log. And so our goal was to prevent duplicate submissions from spamming the log. And it turns out that it's easier said than done. You would think, well, it's just easy. Look at what you have in your log. It's just a database. It's a simple key value lookup. It turns out that logs have a lot of data. And to make them more efficient, we use a lot of batch processes. Deduplication by nature is not something that we can easily batch because this is a one-to-one operation. For each leaf that you have a different key, so you need to do a lookup every time. And this is why we decided to make anti-spam, which is the name of this deduplication process, best effort and asynchronous. So what do we mean by that? It means that when Tessera server runs, there is an asynchronous process that's going to read the log and see what has been added to the log, and is going to populate this anti-spam database asynchronously. Same thing, you can configure it with the Tessera option. But that could fall behind as well. And if you fall too far behind, it means that you cannot deduplicate recent entries, and so you're back to the beginning. Somebody could just submit a lot of duplicate entries to your log. And so same thing here, we hold a watermark to see how up-to-date this anti-spam database is, and if it's falling too far behind, you can just reject submissions. So when we receive requests, we check where we are at. If it's good, we serve the answer. The index might come from this anti-spam database or not, because remember, this is a best effort deduplication. So it could be that anti-spam is running a few seconds behind. And as Andrew said this morning, this is okay. You can have some duplicate entries in your log. This is fine. However, if the anti-spam database is running too far behind, you can just say no to the client, tell them to come back later.
So another log common problem is clients needs to agree on the checkpoint. This is to prevent the log from presenting split view. As everyone said in the keynote this morning, logs without monitoring is useless. So what we need is witness here to countersign the checkpoints. So witness is, so what is witness? So the log would push the consistency proof to the witness, and then which is a very simple external process that checks the consistency and adds the signature to the checkpoint. And then for split view attack, it is malicious logs can provide different views with verifiable signatures to different clients at the same time. So if you look at the diagram, log can provide checkpoint with hash ABC to client A, and then with another checkpoint DEF to client B and C. So with witness, these are external to the log. If you want to run one yourself, you can help the ecosystem, and there will be a witness breakout sections later today. And as I said, checkpoints can be countersigned by the witness. If you see the checkpoint now, there is only one checkpoint ABC that will serve to the client ABC. So with Tessera is quite simple. You just make use of this with witness function that you can provide a configuration. And there is also an option to fail open if the witness are available, but this will be fail close later since the integration with the witness network is new and is failing open for now.
And then yes, we run logs. We need to commit to data output in there, and it's hard. We need to make sure that the log commits to the data that it accepted before it returns anything to clients, which is very linked to this thing that Andrew mentioned, SCTs. So I think if there is one takeaway from this presentation is do not use SCTs. They are here for a reason in certificate transparency, and it's not easy to get rid of them, but they are bad. They give you weaker transparency guarantees. They're really hard to reason about. They lead to outages, so avoid using them. Even if you're designing a new system today that looks really like certificate transparency, try and see if you could get away without SCTs and maybe use inclusion proof directly. This is really important. I think we understand why it's there, but it's causing pain on a day-to-day basis. So nonetheless, how does Tessera handle this? So Tessera will only return things that it has committed to. So once it's returned an index, it means that this entry will be there at that index and it won't be anywhere else. And optionally, you can get stronger guarantees. Here again, depending on the backend implementation, it has a slightly different architecture. So for POSIX, everything is synchronous. Whenever Tessera returns an index, it means that not only the entry will be there at that index, but that it's already there. It's been integrated. The work is done. With the other implementation, as we said earlier, integration is asynchronous, which means that you get an index. It means that the log has committed to putting something there at that index, and the entry will eventually be present at that index a bit later. Usually that happens within a few seconds. Now, if you want to get stronger guarantees, you can wait for publication. So that means that you can wait for the entry to be available there and also to have a checkpoint that publishes it, that commits to it. It's very simple as well. You just enable the publication waiter, and it's as simple as a process in the background is just going to wait. And once the checkpoint is available, it is there. So it's quite nice to use this feature when you run a log yourself, which means that if you return something to your client, you know that everything is there. The client could do that themselves as well, but you can do it server-side. And clients, regardless, should always check when they receive an answer from the log that the entry is indeed over there.
So human can make mistakes, and system outage could also result in data loss. So Tessera's approach is to have the persist data when the future is resolved, and there is no multi-tenancy. So yeah, Tessera will continue to process the in-flight entries, like the entries with sequence number assigned, but not yet integrate into the logs. So no matter how much time how many times you restart the Tessera application, eventually it will process the rest of the entries and integrate into the log. And yeah, so there is, as you can see here, so we only got one log with dedicated servers, log storage, and the state. So hopefully that will help. Another common problem is you will need the visibility to know what's going on in the log. So with Tessera, you got the metrics from the open telemetry. So you can plug this graph in different dashboard. And you can plug this in any monitoring platform like GCP, AWS, and both, yeah, all of them will work natively. And on top of that, you can also see the trace here, like you can see different functions to drill down into each function to find out the latency issue. Yeah, for this one, looks like is waiting for the entry to be integrated to the log. So, any questions?
Thank you for the talk. One of the things that Andrew called out this morning was failure modes where databases took a very long time to restore after a log outage. It seems to me that that's, even though you are relying on a database, that's not going to be the case for you folks, because your database is likely to be quite small, right? It's essentially limited to the size of the outstanding entries plus whatever the anti-spam database is, which you can toss. Is that?
This is correct, yes. The database is not here to hold a lot of data. It's just we need to have something that allows for atomic operations at a global scale, but really it doesn't have a lot of data in there. Like it's like a few megabytes, maybe gigs at most, but it's not a lot.
Cool. And since I have the microphone, so I can just unilaterally ask another question. Your publication awaiter, like what sort of latency are we talking here? Like if you wanted to run on GCP, but you wanted synchronous inclusion, what sort of penalty does that cost you?
Order of seconds. We actually published a checkpoint, I think, every second, 400 milliseconds, something like that, less than 2 seconds, and then the waiter just like will see almost immediately. So it only adds a few seconds.
Yeah, so my question would be, if the publication awaiter is disabled, what would happen if the database were lost?
If you lose the database, then yeah, you will lose the entries that are going to be added to the log. Yeah, this is very true, but I think this is, like, although you have different guarantees, if you use buckets, for instance, it could happen as well. If you lose your disks, then you've lost your data. So I think, like, what do you trust more? Like, do you trust like more central database that has very few data? I don't know. Also depends on which backend you use. And I see that Al has another answer.
A thing to bear in mind is that Tessa is built for all transparency applications, which have sort of different requirements. And so I'm in agreement with you that for Tesseract, you should run with the publication awaiter enabled, because then you get those durability requirements that you want. Other transparency ecosystems will have sort of different approaches. So I think Phil sort of mentioned this earlier. If you have a client that's waiting to log a thing and then it's going to build, say, an offline proof bundle, that integration awaiting is happening anyway, but just outside of the log.
Hi, thank you for all this amazing work. I'm curious about the checkpoints and the witness co-signatures on them, and how fast you expect those to come in, and like who's prompting who? What's the flow of events that makes those signatures happen?
Right, okay. So I'm not an expert in this one, so hopefully I won't say anything wrong. But with Tessera itself is going to push the consistency proofs to the witnesses, and the witnesses will reply as fast as possible. So this is what they push is quite lightweight, because it's just a checkpoint and a consistency proof. And then the witnesses are just waiting, and whenever they receive their request, they compute the consistency proof. If it's okay, they co-sign it, send it back to the log. The more witnesses we have, the better, and then we can decide how many co-signatures we want before we publish the checkpoint. If we want 5, 4, 3, I don't know, it depends. Also, as we said, you can decide whether you want to file open or close. Depending on your ecosystems, you might want to use different settings.
Okay, so is it the case then when you write out a checkpoint that will have however many witnesses you required in your configuration, and then that's done? We will never, if a witness gets back to me like a second later with a co-signature, I'm not going to bother to append the checkpoint or anything.
If the witness comes back and you still have not published a newer checkpoint, I don't know what will happen. Maybe Al knows. But the thing is, if you have published a new checkpoint already, then like the signature is too old anyway, so you cannot use it.
So Tessa is configured with a graph that needs to be satisfied. Where's the person that was asking? There you are. Yeah, Tessa is configured with a graph that needs to be satisfied for sort of, you know, it to have completed the witnessing step, which happens synchronously on publication of a checkpoint. Currently, we publish whatever we've got after some amount of time, but in the future, that will flip the other way, and you'll need to meet the policy before you publish anything. And so Phil's right, you'll get as many signatures as you can within some window of time, and you'll publish or not. We don't try and tack on extra signatures sort of after we've already published, because that gets complicated when you're publishing things to like buckets where you can only write once per second, these sort of things. And then your other question, how long does it take? I mean, we don't really know because there aren't that many witnesses kicking around at the minute, but if looking at sort of the profiles of what we're doing at the moment, we're talking, 100 milliseconds tops.
I'm thinking about how we want to use this in the SIGSUM log server, where we do replication at the application level to a different node. So then you would want to push the stuff into the local tessera tiles, and then you would want to have them replicated to a secondary instance, and when they are reliably stored there, you sign a new tree header or pass it to witnesses, etc. Do you have an easy answer to how to do that in a good way, or is that something we will have to figure out?
I think there are multiple ways of doing it. The best way to do that would just to use a storage system that handles replication itself, and you just offload that problem. You could do that if you use the S3 and MySQL implementation, if you have an S3 storage system that allows you to do this. Now, if you want to do that with the POSIX version, you could just use a file system that handles block replications, but you need to be careful if you do that to make sure that all the properties are guaranteed. Yeah, I would not recommend publishing a checkpoint until you know that everything has been replicated, and that's going to be served by different front ends, because then you could get inconsistencies.
Okay, we will end that session there. Say thank you to Philippe and Roger again. Speak messing up. And next and finally in this group of talks, we have Joe back on the stage to tell us about Merkle tree certificates, I believe.
Hello again. It's been so long, I've missed you. All right. So I'm going to talk about Merkle tree certificates a little bit, which are what if we could redesign the Web API to be sort of post-quantum native, and what would that mean? One of the things you heard from Philippe and Roger just a moment ago was, SCTs are bad. One of the many things we get to do when we think through this again is I can use the slides that are in there if we want, and then is that we can get rid of the original sin that we had of SCTs previously. Oh, look, there we are. Excellent. Once again, I'm Joe. I'm an engineering manager on Chrome. I still don't do any real work, but especially for MTCs, I don't do any real work. I'm presenting work today that is actually authored by some people who are in this room, but all the people on the left and all the people on the right are also doing real work here. So all the kudos to them and none to me. That also means that I'm probably going to say something stupid, and then you can call me out on it during the questions period, and then we will all laugh at me together. Okay, so briefly, what are we doing? I'm going to give sort of a 4-part talk that looks like it's going to be spread out in time, but most of the time is actually going to be spent on this first bullet point of what the heck are Merkle tree certs and why are we building, or why about any of this. For those of you who were at the Transparency.dev community meeting and saw a talk from David Ben, you'll see some of those slides again, so sorry. But I think it's good to sort of revisit this. Then we're going to talk a little bit about what work we are doing to standardize this, and then some experiment that we're running between Chrome and Cloudflare, which will give us some working code in relatively soon here. And then MTCs are a protocol, kinda. There's still a bunch of open policy questions to be had. So I'm going to talk a little bit about what that might look like from Chrome's perspective. All right. Sorry, my monitor isn't working here, so I have to make sure we're all synced. So briefly, post-quantum. The post-quantum algorithm that has gained the most traction in places such as the Web API is MLDSA. MLDSA 44 is the smallest variant of them. And if we just look at what would happen if we swapped out algorithms that we're using today for MLDSA, you'd discover that our public keys and our signatures both grow by a lot. And that's a problem for a couple of reasons, but we tend to put these things everywhere because they used to be cheap. And so that has a big impact on things like the size of our TLS handshakes, where we have 3 or more signatures and 1 or more public keys. And that kind of sucks when you're when all of them are huge. It also sucks for CT logs in particular, because CT logs get a lot bigger because the individual entries get a lot bigger. In CT logs right now, we log 2 types of certs. We have these pre-certs, which only have 1 key and 1 signature-ish. And then often we have final certs that have embedded SCTs in them, in which case the number goes up even more. So if we just moved to MLDSA, we would expect CT logs to grow by about 8.3 times in size with no other changes today. That's a big change, especially when you consider that it's happening at the same time that certificate lifetimes are getting shorter, which is already going to increase the load on CT logs. Okay, so what are MTCs? MTCs sort of flip the script and say, actually, if I'm a CA issuing a certificate, including this certificate in the log is the act of issuing. Ooh, I can see my monitor now. This is great. Thank you so much. It is the act of issuing the certificate. It's not the signature on the certificate itself. So in the old world, we used to sign a certificate and then submit it to the log, and now we issue the certificate by including it in the log, and then we sort of sign the log instead, if that makes sense. So what does that look like in practice? CAs are each going to run their own issuance log, which contains these log entries. Then the CA signs checkpoints on the tree, and then the CA can go and push these checkpoints out to witnesses or mirrors or other things and collect co-signatures back, and that becomes the signature that becomes what is included in the certificate, which is the set of co-signatures that we just collected, along with an inclusion proof in that tree. So no SCTs quite in this world. We actually get the inclusion proof. The log index here also becomes the serial number. There are a couple of other interesting tidbits about how we've structured this that are mostly unimportant. The key thing to keep in mind here is that we get rid of this sign then log operation and replace it with a log then sign the log operation. Once this certificate makes it to a client, say a Chrome client, Chrome will do a similar set of policy checks that it does today with a traditional certificate. It will verify that it'll double check that inclusion proof, and then it's going to check those signatures to make sure it's from a CA that it recognizes, and it's going to check the signatures from mirrors to make sure that it's mirrored adequately. Okay, so why this design? It has a bunch of nice properties. I'm just going to highlight 3 of them very quickly. And let's step through these together. The first one is that it makes the log entries in the CT log way smaller because we can remove all the expensive stuff. We throw out all of the per entry signatures, and we replace all the public keys with hashes, which are nice and small. Again, this is possible because the existence in the log is itself enough to give that non-repudiation property that we got from the signature previously. This change, if enacted today, like if instead of our current Web PKI, we moved to this sort of log structure, we would get an 11x decrease in the size of the logs. If you combine that with the 8.3x increase that we're expecting from PQ, that gives us 2 orders of magnitude that we're saving off of what is going to happen in the PQ world if we don't take an approach like this. We also have fewer log entries in total with this architecture. First off, in today's world, we have this dual certificate situation where we have a pre-certificate and final certificates that also get logged. And then we also have this situation where every certificate can be logged basically everywhere to every CT log. And that means if you're a monitor, you have to go and download every certificate in practice about 2n times, where n is the number of logs that are active for a given period, which kind of sucks. With Merkle tree certs, there's only 1 entry in 1 log. There are these mirrors, but the mirrors are provably identical to the original log, so you only have to download it once and then just verify that everything is as you expect. This gives obviously a 2x entry reduction per log, but again, we get a 28x reduction across the ecosystem in terms of log volume. So hopefully between these 3 slides, you can see that this is like way cheaper from a transparency perspective compared to the status quo. There's another very cool property that Merkle tree certs have, which is that you can have actually 2 forms of a certificate. You can have a certificate that looks kind of like the certificates we have today, where you have these signatures from mirrors and you have a signature from the CA, but you can also have this highly optimized variant. And in this optimized variant, we can drop all of the signatures entirely and still have it work out, which gives way smaller TLS handshakes, which is interesting from my perspective as someone who cares about browsers and performance and stuff like that. Even though it doesn't affect transparency quite as much, it is still cool from a transparency perspective. So how does that work? The key insight here is that inclusion of an entry in the log can be proved up to any future checkpoint. It doesn't have to be the one that's issued at the time that the certificate was included. And so we just designate some periodic checkpoints and call them landmarks. Say we issue one every hour. And then browsers go and validate those check marks out of band. So like Chrome has servers that go and pull down the landmarks and make sure that everything looks good for all of those entries. And then provides those landmarks and the hashes of those landmarks down to the Chrome clients. And then the server just has to prove that there's a way, just has to prove inclusion to one of those already trusted landmarks that Chrome knows about in this case. Not Chrome, arbitrary browser, but I'm Chrome-centric. What do you want? There are a couple of downsides to this, though. One is you can't make the signature list certificate immediately. You just have to wait until the next landmark. And so there's, even in a world where signature list certificates are used a lot, you're still going to need the other certificate, the full certificate sometimes. It also requires that clients are regularly getting these landmarks out of band. And of course, servers and clients have to agree on what landmarks they both understand so that the server can provide the right type of certificate. We're not going to talk too much about that today, but I'm happy to answer some questions about it if you'd like. Merkle tree certs also have a bunch of other neat properties. You can do index-based revocation, which means that you can revoke certificates that you've never seen if you know where in the log they should have been stored. The issuance logs are just tile transparency logs. They are T-log compatible. So like all the cool stuff that Filippo was talking about this morning, Merkle tree certs slot nicely into that, which is nice, and we can reuse a lot of the expertise that we've already built up together. Also, just operationally, these fit now into X509 certificates in sort of a tidy way, where this just sort of looks like a funny signature algorithm in TLS, which is nice because most servers don't actually really look at the certificate very much. They pass it on to their TLS library, and as long as the TLS library handles it, everything should just work. So it reduces the implementation overhead that we expect for servers. And one sort of neat property here is because we're batching signatures based on in the issuance log. Let's say you have an HSM that's really slow or whatever. That's actually okay in this model in a way that it maybe isn't in a traditional PKI. There's also a bunch more cool stuff that happens in Merkle tree certs that I unfortunately don't have time to talk about. There's this whole subtrees concept that makes us be able to shrink the inclusion proofs substantially to make that even more compact. There's a whole idea in Merkle tree certs of certificate of log pruning so that we don't have to rotate logs like we do in CT today. We can sort of just kill off all of the old entries in the logs that we don't care about anymore according to some policy, while still maintaining the Merkle tree cert property. And a whole bunch more cool stuff there too. I encourage you to read the draft if you want to learn all about it. Along those lines, there is a draft you can read right now. The hope is to get this standardized in the IETF. There is currently this fledgling group of PKA logs and tree signatures, or plants, which has a BOF coming up at IETF 124 in Montreal a couple Tuesdays from now. And that's a great place to get involved if you want to, even if you can't come to the BOF. Our hope is that it turns into a working group, and then you could be involved there. If you're like, you know what, IETF's not really my speed, that's okay. You can go comment on the GitHub repo directly. Links right there. there's a lot of cool work there. So there is still a lot of stuff to figure out in MTCs. We have a relatively coherent story that I'm hopefully trying to tell, but my expectation is this will continue to evolve further. It has already evolved once. I should have said this earlier. If you've heard anyone ever talk about photosynthesis, photosynthesis is the latest revision of Merkle tree certs. There was an old version of Merkle tree certs, which was not nearly as cool as the photosynthesis version that I've just presented to you. So lots of opportunity for evolution as time goes on. So in parallel to the standardization work, we're also aiming to demonstrate the viability of Merkle tree certs and work out the kinks by having a real example of them running at scale. And the way we are doing that is in an experiment which is a partnership between Chrome and Cloudflare. For this experiment, we're going to be running it with conventional crypto, so ECDSA and RSA leaf certs and ECDSA cosigners. It's only going to be on the cool signatureless certificate optimization, which lets us sidestep a lot of the policy complexity that I'm about to talk about in a minute. But the goal here is to say, look, we actually see the sort of performance improvements that we'd expect to see. And our hope is, well, actually, I have more to talk about that. Well, one big wrinkle in this whole experiment is that Cloudflare is not currently a public CA, and we don't want this experiment to sort of de facto extend the trust boundary of Chrome to include Cloudflare. And so we have to do a bunch of extra work to make sure that every MTC that's issued corresponds to a valid certificate in the traditional Web PKI. So there's this concept of a bootstrap certificate, and every time Cloudflare will be publishing a cert, they will also be publishing the bootstrap cert sort of in parallel. Then Chrome servers will come along, fetch the logs landmarks, kind of like I talked about earlier, and validate the consistency there, and also go through and make sure that each MTC is not just included in those landmarks that to be expected, but also that it matches this bootstrap certificate, and that trusting the MTC is not any riskier than trusting the corresponding bootstrap certificate would have been. This includes doing things like making sure that those bootstrap certificates pass the CT requirements that Chrome has and stuff like that. Yeah. So once the servers have validated that, Chrome will be pushing those validated landmark hashes down to Chrome clients. Chrome clients will then indicate support for Merkle tree certs in the TLS handshake. And if they get a Merkle tree cert back, they will verify the entry's inclusion proof to the known landmark. This is like active work that's happening right now. Our goal is to have code running in Chrome and between Cloudflare and Chrome in December. So it's like, you know, it's like active. I'm really excited about it. But yeah, that's the experiment. The next big question, though, is that the experiment is great, but it's sort of just a proof of concept, and it relies on this whole bootstrap certificate thing. But we sidestep a lot of the interesting policy questions. MTCs, as I said earlier, is really just a protocol. And so all of the things like root program policies or CT policies that we've had to build out for Chrome now need to be reconsidered in the context of Merkle tree certs. So to give you a little tiny hint of where we're thinking there, this is very early on, but from a root program perspective, our hope is, or our expectation is that if we build out something MTCs related for realsies, not just for an experiment, that it's going to be PQ only in Chrome. We're not going to have any of this conventional nonsense in the MTC root store. But our other big hope is that this will be Chrome's response to publicly trusted PQ certificates. That our hope is not to have a traditional root store with MLDSA roots, which is, I'll point out, different than I've heard some other root programs are taking, but we'll see. Anyway, so then we get to like more of the CT policy half of the equation. There are a bunch of degrees of freedom here that we get to reconsider that we haven't reconsidered or haven't had a chance to consider before. One policy that we could take is just to sort of mirrors doing double duty here. That's poor choice of words on my part. We could duplicate what we do for CT today and require that CAs get co-signatures from two third-party CT or two third-party MTC mirrors, and then we would have an ecosystem of mirrors, just like today we have an ecosystem of logs in CT. we could also recognize that CAs have their own log, and so maybe we say, well, as long as the CA can operate that log and have it be available publicly, according to our expectations, we can actually drop one of those co-signature requirements and say, you actually only need to get one mirror. You count as a copy, and then the mirror counts as a copy, and then you still have 2 copies out on the internet. So that's sort of the top right option. The advantage there is that it's a smaller certificate in the signatured version of the certificate, the full certificate. The downside is that it requires that CAs pick up that slack and actually offer an available log. You can also imagine more aggressive options, like what if instead of having this third-party ecosystem of logs, we instead require that, or the standard is that UAs spin up mirrors, and then we have a policy that looks kind of like today's CT policy, but instead of having logs operated by third parties, they're operated by the browsers or something similar to that. This is great, in my opinion, because UAs have an incentive to do this right now, and it's sort of running a log is a pure cost center. So we've talked in the past about the difficulty of finding folks to volunteer to run logs, and this sort of sidesteps that problem. We could even take a more aggressive position and say, actually, if you want your cert to work in Chrome, you can go register it with Chrome's mirror. Or if you want it to work in Firefox, you go register it with Firefox's mirror. And one of the things that MTCs allows is for you to negotiate what certificate you want to provide to the client. And so you could actually provide different variants of the certificate to each different browser and have it still work everywhere. And the advantage to this is that it's much smaller in terms of the TLS handshake still, because now you're down to just a single signature potentially. So there's a bunch of different degrees of freedom here. Hopefully we can talk about this maybe in a breakout session if you want to talk about it more, and we'll go from there. And that's all I got today, which is good because I've got very little time left. Thank you very much.
I believe that Chrome enterprise settings can make it possible for you to disallow specific routes from the Chrome root store, and this would maybe impact the Cloudflare test, because then you can't on a server tell what certificates would be accepted.
I don't actually think there's an enterprise policy that lets you remove individual routes from our root store. But
okay, maybe I'm just wrong about that.
But I'm confident that we'll take care of that case. That's a good call out, though.
Yeah. So revocation checking is currently quite a pain point in current web PKI. So the solution is on the same lines with CRL Lite or CRL sets.
So I have a hot take here, which is that I think revocation checking is actually fine in the web PKI right now, in no small part due to tremendous amount of work that has been put in over the past couple of years by multiple browsers. So MTCs already have this mechanism where we can deliver revocation information down alongside the landmarks. We're not going to do that for the experiment. MTCs are also very likely, as we've written them, only to be short-lived certificates. If we sort of mirror what the baseline requirements from the CAB forum right now look like for short-lived certificates, you actually can get a pass entirely for supporting revocation at all, and so we don't have to enforce revocation in the browser either. In practice, during our experiment, actually, the Bootstrap certificates and the MTCs are going to have matching SPKIs, which means that actually our current revocation mechanisms in Chrome will just magically work on MTCs, which is kind of neat. Right now, today in Chrome, certificates that are revoked by the CA for things like key compromise are already enforced in Chrome. So we will sort of
CRL sets, right?
This is using CRL sets, yeah.
Thank you.
Yeah.
Is it too early to ask you for an ETA on when public CAs should need to implement this?
So my hope is that we will have a lot of the kinks worked out next year. And so 2027 would be the year of actually doing this for real in some fashion. But that's an ambitious timeline because this sort of stuff is slow.
So you mentioned that clients have to negotiate with the server as to which landmark they will accept a proof with respect to. How do you balance that with possible fingerprinting vectors?
Right, great question. So there are a fairly limited number of landmarks per, well, how do I say this? Every up-to-date client, roughly speaking, will have the same set of landmarks available to them. So the fingerprinting question only gets interesting if you have clients who are sort of lagging behind. And it's really only interesting for clients that are lagging a lot behind, because if they're only lagging a little bit behind and they're still getting updates, it's not a stable fingerprint, right? 10 minutes from now, they're finally going to get the update, and then they're going to have a different fingerprint. So it's only interesting for the long cases. And the short answer there is if you don't get an update with these landmarks are only good for on the order of a week, and we're probably going to cut it off less than that. So if we haven't gotten an update in the last 4 days, we're just not going to send the set of landmarks with our requests out, so it won't be usable for a fingerprint.
Yes, thank you. The current recommendation for MLDSA and other post-quantum candidates are like, we should keep the regular crypto around because the cryptographic community is not sure about the new post-quantum stuff being safe from catastrophic failure. And in a similar way, when I look at MTC and the city ecosystem does not look safe now from catastrophic failures, though is there like plans for hybrid certificates between the regular way, old way of doing certificates with the new MTC ways, or just let's move to the new stuff and forget about the old stuff?
MTC's, the protocol is pretty actually agnostic about what algorithms you're using. You could build it out using hybrid algorithms if you wanted to. A lot of those details will be worked out as it goes through the IATF, I'm sure, and debated at length.
I think I was making an analogy. So if the MTC is the new way of doing certificates, but we are not safe from the transparency environment failing, because as we saw this morning, we still have failure modes, and it's still at the early stage of the transparency in some ways. There is already a decade of measurements, but we still have like logs dying in 2025.
Yeah.
So what happens if tomorrow, like the MTC logs die, and we cannot recover from that? Will we have still like regular signatures in our certificates to be able to resume the works? Or
so there's a lot of work to be done in terms of making sure that there's enough sort of wiggle room so that when a CA screws up, that it doesn't cause catastrophic failures for them or their customers. There is a significant increase in the stakes are higher that you run your MTC log better than we are running CT logs today, and that's probably unavoidable. The best thing I can say here is we've got some time yet to figure this out. I think we've seen tremendous improvements in terms of reliability of logs in the past 2 years, and I think that even if we were to build out MTCs tomorrow and have them be ready, like it's going to be a while before in the public web PKI, PQ certs are really at critical mass in some senses. So that's a risk. I think we've got some time to figure it out, and I don't think things are as bad as they could be. Yeah.
Joe, in your presentation, you sort of mentioned supplanting HSTS as well. I don't think you have time to talk about it, but could you give us a couple of sentences on what you might envisage there?
So I don't think I mentioned HSTS except for mentioning that it's something that my team is within our team's remit. I don't like HSTS, but I'm not yet sure if MTCs will play into that, other than I hope that we're in a HTTPS, basically universal HTTPS world by the time that MTCs are the law of the land.
Absolutely. I mean, being HTTPS only seems pretty much definite, but being PQ only?
Yeah, so
tricky.
there is not a world where we're in. There is very likely to be something that looks kind of like HSTS preload for PQ. That's some flavor of that is unavoidable. We have not investigated that at great length. It's a good question.
Yeah, so have you considered something sort of HSTS-like to require the use of landmarks? Because it seems to me that would provide a much stronger property than relying on co-signatures.
That's interesting. I don't think we've considered that, but we could. It changes the way that you get and use your certificates in a major way, and so it's not something that you'd want folks to adopt without due consideration. But I don't hate it. Yeah. That's one of the many questions we can answer together if you want. Yeah, make noise in the working group.
Yeah, and then actually I had one other question, which was for this Cloudflare experiment. Will the logs and the landmarks be public so that monitors can monitor them?
I think we probably could. I can't speak for Cloudflare, but I don't see why not. The URLs actually are available if you can divine them. They're already publicly accessible. So I suspect that I know that there are blog posts planned from both of us, and I wouldn't be surprised at all if that was something that was included. Excellent. Look, hello. Did not realize you were here.
All right, I think the last question.
As I understood it, the landmark would be a tree head, right? Then it would make sense to distribute that together with the log signature and co-signatures.
Yes.
And then you could monitor them like you would monitor.
So no matter what variant you use in a Merkle tree certificate, you will have access to a tree head that includes that certificate. It may just be some random checkpoint that was issued at the same time as the certificate was issued, in the case of the full certificate, or it might be a landmark that happens sometime later in the event of the signatureless variant. But either way, you will have a tree head that can be used to show inclusion of the certificate in question.
Okay, round of applause for Joe, please.
Thank you.
Take your spot again. Okay, so that is the end of our first afternoon talk session. Next, we have the breakout sessions. We will take a break before the breakout sessions. But I think up there at the moment, we have 3 sessions that have been, is that right? Just people who are close to it, that have been suggested so far. I know in a couple of the talks that have happened this afternoon, people have said, maybe we can have a breakout session on it. Looking at you, Joe, looking at the breakout sessions. So feel free to add to it. If anyone has any last minute ideas right now, feel free to go and add them. What we would like you to do is during the break, which will run from now until 4, again, there'll be even more to eat outside. If you can, maybe towards the end of the session, maybe now, whenever you have some time, pop over there and just put a dot. You'll see there are some dots underneath the session you plan to go to, so that we have a rough idea of numbers and can figure out where to put each session. We will then run the session from 4 till 4:45, I believe, where discussion in groups will occur. And then at 4:45, we'll come back here together and we will have a collective summary. So ideally one person, probably the session leader, makes sense. We'll just give a bit of a summary about what was discussed, and if any amazing insights were found, that would be great. And then after that, we will have our final 2 talks. So yes, if you could do all of that during the break, that would be great. Also, a couple of people have already come up to me about the unscheduled lightning talks. I know I said come back when I have my laptop. I now have my laptop, so come back and let me know, and I'll write your names down. If anyone else has had any ideas about unscheduled lightning talks, come let me know. See you all at 4. Hello. Oh, hello. Oh, there's a big whiteboard in the way. We'll deal with the whiteboard. Everyone could maybe take a seat. We're going to do some breakout session summaries, which is the reason that I'm holding 2 microphones. It's not just for this, which I don't think, this one's not on yet, is it? Who knows? Okay, so we had 3 breakout sessions. From how reluctant you have been to end them and to come back into this room, it sounds like everyone's had some really productive discussions, which is great to hear. I'm just going to stand here and ramble about how great to hear it is until people have settled a bit more. So we just want from each, probably the leader of each session, if you're happy to do it, just come up, say a little bit about what was discussed, just a few minutes, and then once that's done, we will move on to our final 2 talks of the day before Fun and Games this evening. So, Rasmus, is it you, or is it Al, or Filippo? I don't know, one of the witness, we'll do witness number 1, and then onwards.
I was delegated as a witness of the session by Erasmus. Okay. Tough crowd. No, okay. So we talked about the witness network. We talked about what do log operators need to know from witnesses to pick witnesses for their policies, and what do witness operators need to know and provide to offer reliable and useful services. So we talked about the various dimensions that one can evaluate a witness on, which go from raw capacity in terms of QPS, in terms of space, but also latency, but also a list that I am immediately forgetting. But the various different things that you would want to know as building a policy. We talked about how to build policies and how we can provide recommendations, and we answered it depends on the ecosystem a lot, because most things do depend on the ecosystem. But we talked about what kind of things we can suggest ecosystems think about. And we talked about how large generally you want policies to be. We probably don't want to have 1,000 witnesses where you start having to worry about Sybil attacks and so on. Although having a list of 100 witnesses to pick from to build your policy, that sounds great. That sounds like success. Am I forgetting anything, folks? All right, excellent. And witness-network.org is a thing, so you can keep up and participate. There's a mailing list.
Amazing. I'll can take it off you. Next, who would like to go next? MTCs or Elena? Do you witnessing part 2? Was it also?
Yeah, exactly. Yeah. So like, if you have 100 witnesses, how many should you actually check to be sure you're not vulnerable to a split view attack? So that was what we were discussing, how to get consistency. And it turns out that you wish your witnesses to always be online and always reply with correct signatures. Otherwise, it's a bit hard to provably know what's going wrong. And B, you can have a sort of dual policy where maybe the monitor is checking more signature than you as a verifier, but the sum of the signature you're checking needs to be higher than the total number of witnesses in your policy, because you need to make sure that you overlap in at least one honest witness. So it turns out that you need to check more than you think.
Great summary. More than you think. And do we have someone from Joe's 3rd time today? On this stage, different type of microphone.
Yeah, I don't get my Britney mic this time. I'm just waiting. We had a breakout about mostly motivated by that policy question that I hinted at the end of my talk about like what should the policy, the equivalent of the CT policy or root program policy look like for MTCs. We spent a lot of time talking about that, but we also sort of veered off onto some other MTC-related topics. One of the things that I secretly wanted from this breakout, which I got, was sort of a sense of some of the concerns from folks who might be in a position to implement MTCs either from a CA perspective or a mirror perspective or a UA perspective. And I think that there was rightly a strong identification that MTCs right now don't have a strong story, or at least not a well-specified story, for things like root rotation and having a story for supporting devices that don't have tight update cycles like browsers do. And while that's part of the design expectation of MTCs, having a coherent story about how to bridge those two ecosystems so that we don't end up with further bifurcation into multiple sets of hierarchies was good. What else? Among the policy front, I think there were some interesting points brought up about, while there was interest, for instance, in having CAs be able to get away with fewer signatures if they were running, their issuance log publicly, there was also interest in some CAs operating their logs, being able to continue to operate their CT mirrors quite discreetly from their issuance pipelines. And so that was a point that I hadn't considered in great depth. What else did we discuss? Fun MTC friends. Yeah, I talked a bit about rotation. That's important. Both when we talk about rotation, rotation and like mirror rotation as well. And of course, yes, enterprise, the big question mark behind what we do for enterprise. So, yeah, that's it, I think. Thank you much.
Great. Thank you, everyone. Feel free to, I know, I did interrupt quite a few of those conversations. Everyone seemed to be really into it. So do feel free to continue those conversations outside of the room this evening onwards. That's part of why we're here, is this natural discussion that happens. So keep it going. Okay, now for our final. I know some of the people who have traveled quite far are starting to feel the jet lag. So our final session of today will hopefully be riveting. It's efficient and effective monitoring. We have 2 talks for you, both by our program committee chairs. So give it up for Rasmus, who will be starting off this session.
All right, I'm Rasmus from Glasklar Teknik. I contribute a lot to the SIGSUM project. But now I'm going to talk about my side hustle or my passion project, which is definitely going to be done by Monday, similar to Dennis' project, which is Silent CT, a certificate transparency monitor that filters out the noise. And if that sounds vaguely familiar, or if perhaps I look vaguely familiar, then that's because I gave this talk last time. There we go. Same shirt, same cap, different microphone. And to bring you up to speed, last year I told you basically, why does Silent CT need to exist? So whenever you're running a CT monitor, then you're basically getting every certificate from the log. So whenever there's a renewal or you get a new certificate, then you would get a notification. So if you have a lot of sites, that means you get a lot of notifications. What I would like to build is something that's silent. So I would like you to only be notified if there is an unexpected certificate for your site. So, for example, there's a misconfiguration or there's an actual certificate misissuance. And unless that's the case, then I want this to be dead silent. All right, so the setting I'm plugging into here is that you might be running your own website, so like your personal website, and you have like certbot and you're getting some Let's Encrypt certificates. Perhaps you're running multiple websites, or perhaps you're having multiple different hostings of the same website, so you have multiple things requesting certificates. Or maybe you have like a central component which is requesting certificates, and then you will push that to a website. So in order to get this sort of silent setup, then I'm going to make a fundamental trust assumptions, which is these systems that acquire the certificates, they're going to be trusted. So that is going to be like my baseline for how am I going to filter out the noise. If you can't trust those systems, then I'm sorry, I can't help you. So to give you an overview of how this works, then to the left here, we basically have a regular certificate transparency monitor. You go to the logs, you download each and every entry and spend lots and lots of megabits per second to do that. And you'll end up with a list with here are all of the certificates for your domain. And then you're also going to combine this and you're going to pull these, what are the expected certificates from your trusted infrastructure, and you're going to compile a different allow list. And if those lists are the same, then you're happy and this monitor is not going to make a noise. But whenever they diverge and you find a certificate that you did not allow list, then you know that there's an issue. So maybe there's a misconfiguration or there has been misissuance, and that's the one you want to investigate. And when you're running this silent CT monitor, then of course you need to trust this monitor, you need to trust whatever is pushing out the notifications. So if that is compromised, then I also can't help you. So concretely, if you're going to use this, so this is from my own personal website. So I'm using Let's Encrypt with Certbot. And all I need to do is to add a post hook so that whenever there's a new certificate that has been issued, then I'm going to run this silent CT MAC tool. And all it does is it basically puts a symmetric signature onto this certificate. And now my monitor will be able to know that this certificate has actually been allow listed cryptographically from this trusted system. So for example, you could pull this as a monitor, and then you could check that, yeah, it's from this particular system, here's the cryptographic MAC address, and here's the actual certificate. And then it knows it's originating from the system. Now, the way you would run this as a monitor, you need the configuration, and this is actually what I'm running for my own monitor. So I have to say which time am I going to start running the monitor from. So everything that happened in the past, I'm going to ignore, so I don't need to download a backlog, for example. Then I have to say, what are the certificates that I want, or like the domain names that I want to match on. So in this case, I want everything that matches rgdd.se. And then I have one trusted certificate requester. So it's going to have this shared secret that the monitor is using to verify, am I getting the allow list correctly? It's going to have a location where it pulls these allow listed certificates. Then I also have a way to specify what are the domains that are actually allowed to be in the certificate. So if that should go and be different, then this monitor will also detect that. So then you just click play, and it's going to figure out which logs to use. It's going to use the list that Jo was talking about earlier, and if you're unable to update that for a significant amount of time, like 30 days or something like that, then the monitor will stop and scream to the operator and not be silent anymore, which is great. So you can run this thing, and if there's an issue, then it will print a notice to standard out, and you can also pick out these via Prometheus metrics. So all working pretty well, I would say. So far, I've run it for roughly a year, and I have one major pay point, which is sometimes bad and sometimes okay. And it's those rate limits. So every now and then there's a log that's a bit too restrictive, and then I have to sort of escalate this as a warning, because if I'm falling behind, I need to do something about it. So I haven't had any issues with the silent property from the perspective of unexpected certificates, but I get a lot of the rate limit issues that I'm sort of having to escalate. So the good news is that if we have things like the static CT API, which is going to make this better, then also this will be good for the silent CT monitor that really wants no operational issues, basically. So to start summing up here, silent CT is about being notified only about the unexpected certificates. So this would be only the ones, basically you have an unexpected certificate if it's not been allow listed by one of your trusted systems. Everything else we will escalate up to the operator. And this is an open source implementation that you run yourself and just do those 2 configuration steps that I showed earlier. Just click play, and it's going to work for the most part, other than sometimes having some rate limit issues. So in the future, I would like to add support for this static CT API, so I'm currently not supporting it, and that's on the top of the list to sort of add. I would like to add an async running mode, so right now you have to sort of run this on a server and it runs all the time. And it would be really cool to be able to run this in CI pipelines, for example, on the clock, like every hour. And then it's also quite expensive to run your own monitor, so it's many tens of megabits per second. So I would like to make that a few megabytes per day. And if that sounds like magic, or how would you even do that, then the good news is that that's the next talk by Martin. So I'm going to leave that for Martin. That is it, folks. There are a bunch of links that you can check out. So there's the Silent CT repo with the open source implementation, there's the slides, and there's also my speaker info. Happy to take questions.
Questions?
Thank you for the talk. I think maybe you said something about that, but how do you authenticate the allow list?
Yes, I'm having a shared secret between the monitor and the system. So it's basically a cryptographic MAC. And then just compute the MAC with the shared secret, and then only the monitor and the trusted system is able to determine has this been allowed.
And you distribute that manually?
Yes. And you can have one per system, or you could have one for all of your systems if you wanted to. It's up to you. But you as a third party, for example, you can't make sense out of my allow listing for my personal site because it's a symmetric secret.
So yes, so this allow list you have, it is about looking at those endpoints or domains if those certificates are used, right?
Yeah, so the allow list is populated by like the same system that requests the certificate, and then you get a certificate chain. Then I just compute a MAC on that, and I will publish it on a website's endpoint, basically. So I already have a site, and I just put it on an arbitrary domain or arbitrary link, and then my monitor can pull that one.
So if adversary issues the certificate with like same subject names,
yes,
and use it on some other website, will it detect that?
Is there a question if it asks for a different domain name in the certificate, will it detect that?
No, if I request the same set of domain names that like my certificate is, I would request exactly same set of common name as well as subject alternate names. And so will that be detected?
Will it be detected that the certificate has been issued? What's your question? Sorry, I don't understand it.
So I mean, the allow list works on monitoring your actual endpoints or just matching the subject names that you specify in the allow list?
Okay, so the monitor always pulls everything that shows up at the endpoint, but it also pulls everything from the CT logs, right? So it's basically populating two databases, one that you're pulling from your sites and one that you're pulling from the CT logs, and then it computes the difference between those. And whenever they diverge, that's when you escalate that to an alert.
Okay, yeah, so we do something similar on Hardenized. We call it high assurance CT. But we also have like allow list for CAs. So these are the trusted CAs. If the certificate is only from them, then that's not escalated. We also have like if that the certificate that is issued is seen on one of your endpoints, so it's seen on your trusted infrastructure. Then it's also silent kind of thing.
So, I mean, you could definitely build it that way. I don't currently do that with like pinning it on a particular certificate authority. Now it's instead, is the process that requesting it, has it sort of blessed the certificate, then it will not be notified.
Got it, thanks.
Any more? Excuse me. Yes, one here.
If it's completely silent because there's no misissuance, how do you know it's still running and hasn't broken?
I'm collecting the Prometheus metrics from it, like basically hourly. And whenever I'm unable to collect the Prometheus metrics, then something screams. And if that thing dies, well, then I don't know. So I have a cron job on both my laptop and my NUC, and that one will go and look at the Prometheus metrics, and then it will give me some alerts on my screen. And whenever it fails to SSH to the server and then get to the right place, then it's sad.
Any more? It always comes out louder than I expected to. Okay, another big round of applause for Rasmus for his great talk and everything he's done helping set up the schedule. And next, finally today, I believe we have Martin, who's going to talk to us from Scotland. Hi, Martin. Who's there? I'll hand over to you, Martin.
All right, brilliant. Thank you, everybody. Yeah, sorry I can't be there. It's a real shame and not what I expected to be here, but here we are and we'll make the best of it. So hopefully this, the last talk of the day, it's not going to kill the energy in the room being remote. So yeah, I'm Martin. I'm from the Trust Fabric team at Google, and I'm here to tell you about verifiable indexes. So first, we're going to go through like what problem verifiable indexes solve, So it's kind of been hinted at a few times today. There's a bit of a usability problem with large logs, and this usability problem kind of gets in the way of realizing the full benefits of security that we can get from a transparency ecosystem. But fear not, the solution is a verifiable index. And then so I'll go and explain what the verifiable index is from the user's point of view and how it can be verified. And finally, I'm going to spend a bit of time trying to encourage people to get involved. So we've got something that works right now, but it's about making it real in the real world. And so that's why I'm kind of excited to talk to everybody. So what is the usability problem with transparency logs? And basically, it's how hard it is to find your own stuff in them, right? So if you're a domain owner, I mean, it's kind of what Rasmus has just been talking about here, right? If you're a domain owner and you want to find all the certificates for your domain in a certificate transparency log, you've got a lot of other people's certificates to go through. In fact, the vast majority of them, no matter who you are going to be other people's certificates. And that's not just the case with certificate transparency. Other large log ecosystems also have kind of problems like this. So for example, Filippo was talking about SumDB earlier, and that's an example I'll come to a few times through this presentation. But yeah, if you're a module maintainer and you want to find usages, all the statements that have been made about your module in the logs, then again, you've got to go through lots of the people's stuff, and SigSum and SigStore with signing or identity transparency also have this same problem. So, all right, it's hard to find your stuff in there, but why is that even a big deal, and why should we care? I think let's take a little step back and just kind of remind ourselves what the point of transparency is. And really, the point of verifiable logs is to make sure that we all see the same view of data, and that's what we call transparency. And just because something is stored transparently doesn't mean that it's actually going to be seen, and that's a problem, right? Like, it's the ability to see any bad things in there, notify the right people, and take action against them that actually fixes any badness happening in the system, much like weeding kind of a garden bed, for example, right? So in certificate transparency, who can tell if a certificate for your domain was legitimately requested? And I think the answer is you, really. Other people might be able to have a best guess, but you as the domain owner are the only person who can authoritatively say that. So in certificate transparency, it needs to be easy and it needs to be secure for you to find the certificates for your domain. And the same goes for all the other ecosystems too. So how are users finding the data in logs today? And I think a large majority of people aren't, and maybe that's because they don't know that the logs exist or how to go through them, or maybe it's just because it seems like a lot of work. But either way, it means that if people aren't looking, the people who can authoritatively say whether something is good or bad aren't looking at that stuff in logs, and that means malicious behavior might not get detected, and that's obviously bad. Now, a step up from there is people using indexes of any kind. Now, there's a lot of unverifiable indexes in the world at the moment, and using those is obviously miles better than not doing anything at all. But it's unverified, right? We've had verifiable data structures to store the things, but at the point of use not having them, that's obviously, it's unfortunate. It means that entries could be hidden from users, whether maliciously or through bugs, and users would be none the wiser. And then finally, like Rasmus has just been talking about this, how can you do it verifiably? Well, the only way to do that is to download the whole contents of the logs onto your machine and then kind of go through them. And that's what Silent CT Monitor does, and it does it nicely and silently, but it's expensive somewhat for the user. You've got to have the infrastructure to be running this, and Prometheus or whatever. Yeah, but really it's expensive for the log ecosystem. We've talked a lot today, I think it's been a recurring theme about how log serving's expensive. Imagine if every domain owner in the world tomorrow just went, oh yes, Silent CT Monitor sounds great, and launched it. We're going to have a pretty expensive tomorrow, aren't we? But what if we could get the best of both of these worlds, right? So we could get the benefits of the index, but we could get the verified parts, and maybe we could call it a verifiable index. And so we can, and that's what we've called it. And yeah, the users can basically get fast lookups that are lightweight. They just get in the contents that they've asked for, and it's verifiable all the way to their machine. The log benefits because not every single user who's verifying the contents of the logs is scraping the whole contents of the logs. They serve the log once to the index, and the index serves it to the people, and then the people can come and just get their parts of the log. And the fact that this should make it easier and more reliable to make sure that there's no badness there raises the security property and kind of makes everyone safer. So let's go and have a look at kind of what this looks like from a command line point of view here. So like at the heart of it is basically, like I said, like the index in the back of a book. You give it a keyword and then it tells you all the places you can find stuff about that keyword. So here's an example that's based on the GoSum database, GoChecksum module proxy. We're looking for the module github.com/transparency.dev/tessera, and it says, hey, here's all the locations you can find that. And you'll have to trust me, this is verifiable, or you can look in the code. And so this is all verified, but I mean, okay, that's the heart of what the index actually is, but it's not massively exciting or compelling, I don't think there. So let's take it a step further and make it so that if it knows where the input log is, it can dereference these pointers effectively and get you the content from the log. And that's what this does. And you can see here that the module name we've searched for Tessera comes up in all of the leaves. So the index is at least working there. And then along next to the module name, we see the version name. And then alongside that, there's a couple of hashes. So that's SumDB's view of the world. And we've now verifiably pulled that down to our machine. But still, like, we can go a little bit further again, right? Because if I give this to somebody who's a Go developer and says, there you go, this solves the problem that you've got, they'll say, I don't have a problem that looks like that. So this, I think, is a little bit more compelling, or maybe fully compelling. I think this is quite cool. So this meets the Go developers where they are, and you have this SumDB verify command that you point to a git checkout of your Go module. It inspects there, finds the Go module file, and finds the module name, does the lookup that we've just seen on the last slide, and then it's got all of that content verifiably locally, and then it can inspect the Git module, the Git repository, and look for the tags that are there. And if it finds the Git tag, then you get the first of those ticks in each row. Then it checks that the Go mod file matches the hash that SumDB had, and then you get another tick, and finally produces the zip file and checks that all the source that your users have depended on matches what you've got in your Git module. So yeah, that's it. And I think this is really cool. This like closes the loop, right? So what you have published as a Go, as a binary, author, is what your users have downloaded on, and it's all verifiably checked on your machine here. And it's all done without scraping the whole log contents locally. We're querying the verifiable index and checking it locally. And I think another cool property just to notice from this, it kind of hides away all of the log and the index stuff. The data structures themselves become transparent, and we've got a real kind of user experience that's focused on where they are rather than the crypto stuff. So that's pretty cool. And I think we can imagine, hopefully there's people in the room imagining, oh, I could build a tool like that, like Silent CT Monitor could use this, for example, or other ways of doing it for CT and for identity transparency as well. And I'd love to work with people. That'll be one of my appeals at the end. I'd love to make those a reality, but I'm going to need other people's help, I think, to do that. Okay, so hopefully that's compelling, and people are now seeing, like, okay, yeah, that seems good. That solves a real problem, and I can see that we can build real tools on top of it. But an appeal to magic that it's a verifiable index without explaining how it's verified is a bit too much of a leap, I think, for a conference like this. So let's have a look at how it could be built, right? So a URL like that, where you basically pass in the key or a hash of the key, and that's what you're looking for, and then it returns all of the pointers basically into the input log. Great, as a basis, that's kind of what we have in the world today with the unverified indexes, but it's not verifiable. So how can we make it verifiable? Well, we'll just commit to the keys and values in a cryptographic data structure, so that the key is the sort of path through the tree, and then the value gets hashed at the bottom, and then you can get an inclusion proof. So you get the pointers back, you get the leaf node, and then you get the proof through that, and you get the verifiable index route in there as well. So, okay, great. Now you can do an inclusion or a non-inclusion proof, but it doesn't really help us if you could give everybody different hashes and basically it's split views. But hang on, split views, we know how to solve split views, don't we? So how do you do it? You stick it in a log, and then you get a response that looks like this. And this is the final response. in addition to all the stuff we had, we moved the verifiable index into a leaf of the verifiable index root goes into the leaf of a log, and then you get an inclusion proof and a checkpoint that's witnessed for that. And now you know that it's not, that it is fully verifiable. And we'll come back to how that's verified at the end. But I kind of want to address a bit of a elephant maybe in the room, or things that making people uncomfortable, that there's like quite a lot of data structures appearing. So the first one of these we already had, the input log there in blue is the log that we're indexing. The verifiable index in red is a sparse Merkle tree committing to the keys and values. And then finally, the output log in a cyan is there. It has all the index roots in there. It prevents split views, and it makes sure that we've got an audit trail. And we'll get onto how the audit kind of how the construction of that verifiable index could be verified afterwards. But let's go back to the start of the whole kind of journey, right? You've got an input log and you want to index it. How are you going to do that? So let's consider it like the index in the back of a book. If somebody gave you, a book and said, create me an index in the back of this book, how would you do it? Well, you take each page and you identify what the keywords are on each of the pages, and then you know what the page number is, and you put those in the index at the back. Sort of job done, right? And that's very similar to what we do here. This map function takes a leaf entry, and then it parses it, does whatever's needed in the business logic to determine what the keys are that should point to this, and then it returns a hash of those keys. And that's kind of it. Some of this stuff might change. The little icon in the top right there is sort of pointing at, like, there's things here that may well change. So for example, this is returning a hash of the keys at the moment. Maybe we should return the keys themselves directly, which would allow us to build prefix trees and other kinds of data structures. But at the moment, they're fixed size hashes. That's one of the things that we can kind of change afterwards, with discussion. But the important property to take from this is that it's deterministic, because that will impact whether it can be reproducibly built. And then, you don't have to return any keywords. You can return nothing if some entry is not particularly interesting, or you can return multiple keywords as well. So for example, in CT, this would parse out the X509 certificate. It would extract all the DNS names and the IP names from there, and then return the hashes of them. And then the verifiable index code takes care of updating those into the index. But what is the index itself? Well, the version we have at the moment is a sparse Merkle tree. It's actually compatible with AKD. It's fully ported their code across into Go, which is great. That said, we're looking at other data structures at the moment that might allow us to go quite a lot faster. So these things, again, might change, hence the icon there in the top right. The values are just uint64s, they're pointers into the input log, and the leaf hash can be deterministically determined from the values. At the moment, we just kind of append them all together with a big endian encoding and then hash it, but that could be a Merkle tree or something else if somebody has a compelling motivation that we could change that. And when we update the verifiable index, we do so atomically in batches, making sure that the index state that we're serving always matches to an input log checkpoint. And that's a big part of the verifiable story, and we'll have a look at verifying that later on. Once we apply that batch to the verifiable index Merkle tree, and we roll it all up, we'll get a new root. We put that root in the output log, and then we get the new output log checkpoint, and that gets witnessed, and that holds us accountable to that, and we can't go back on it. And then that's what gets used in that lookup. Quickly, we'll take a detour via the output log. I said that it has the verifiable index root hash in there, and it does. It also commits to the input log checkpoint that we used to get there. And I think that's really cool, because those of you that know me know that I love my claims. And this is a falsifiable claim that can be made here, right? The index operator makes the claim that if you index a log, this input log here, that with this size and this root hash, with the map function we know about, then you will end up with a verifiable index with this root hash. I mean, that's almost clear how we'll falsify that, but we'll revisit that in a little bit. I want to first come back to how the client basically verifies this proof that we talked about. Now that we know about all of the data structures and how they're related to each other and what their purpose is, let's walk through how the believer is going to verify this because it's kind of a lot of stuff that may be a bit hard to unpack, right? So it's all about checking the corner of the world that your believer cares about, right? So maybe you with your domain, that there's a cryptographic proof that ties up to something that everybody agrees about, which is the output log checkpoint. So we'll check that the output log checkpoint is signed and witnessed appropriately. Cool. And then we check the inclusion proof within the output log to get the leaf. We know what's in the leaf. It's a verifiable index root as one of the things. So we can pull that out, and then we can use that along with the proof that's there to check that the values we're going to rely on are committed in there. And at that point, we've convinced ourselves that our little corner of the world is completely tied nicely into the thing that everybody's witnessed and is agreeing on. So we're all on the same page. So the only thing now that could mislead us is if the verifiable index itself was constructed badly. But that's part of the verifiable index, right? So let's check how that's guaranteed. It's pretty simple, actually. So we've already discussed how you build the verifiable index from the input log. And we've already shown that the output log contains these falsifiable claims, right, with the input log checkpoint of a verifiable root hash, the index root hash. And so anybody else with enough compute power and interest can come along, take any one of those claims, or all of them ideally. You get the input log, make sure that it matches that input log checkpoint, and then you build the verifiable index yourself. And if you've got a different root hash at the end of it, then you've got a reason to start a pretty tricky conversation. But probably they'll match. This is an important part, by the way, of why it's so important that that function earlier was deterministic, because obviously if it wasn't, then you might end up with different root hashes. Okay, so that's the little walk through how all of that kind of works. Now I want to kind of, try and invite people to come and get along, get involved, join in with what we're doing here. And how can you give or receive the gift of fast lookups to your loved ones this Christmas? So the prototype is there in Transparency.dev /incubator in GitHub. And in there is a library that does the index construction. You basically provide it a map function and the input log, and it does everything else sort of for you. You just crank the handle and say, build it again. And there's also some client library code that checks all of those proofs that we looked at that big chain earlier. And then you can run your own applications with that. So the full source for the Go SumDB one that I showed earlier for the SumDB verify command is there. So all of the code for building the verifiable index from SumDB log itself, and the client tool that checks your Go repository is all legit, and all the Git hashes match with what's in SumDB. And there's also a demo in the log and map demo, it's called, which checks, which basically shows how do you run your own log. It uses Tessera, put your own stuff in, whatever that is, and then how do you run a map, a verifiable index alongside that with your own map function to extract all the stuff, and how do you serve them all. So there should be something in there that you can adapt for whatever you're wanting to do. So possible changes, I'm only going to whiz through this actually because there's not a lot of time. There's a lot of stuff, as you may have seen while we're going through the deck, that may well change, including like how the core verifiable index itself, the data structure that's used there. One of the things that might be cool to do would be implement the map function using WASM, so that we could have different implementations of the core library. It's the verifiable index library in different languages, but still be able to port this map function across without constantly firefighting small differences in, say, libraries and how they implement X509. It's a shame that I'm not there in person, because I really was looking forward to chatting to a lot of people about this and how we can make it real for CT. The biggest hurdle is that the verifiable index at the moment it's a one-to-one. So you've got one log and you get one index. Obviously, that's going to get quite messy for CT, where there's like quite a lot of logs from different operators and shards. So what if we can find some way to make the verifiable index be kind of have multiple logs kind of fed into it and still maintain that verifiability? I think that's possible, and we've got some ideas for how that can be done, although it obviously makes things a little bit trickier. But that's an important part of, I think, what could come next. And then, get involved in other ways. So obviously experiment with the demos. If you're a Go developer, please try out the SumDB verify thing there. Deploy your own verifiable index. And here's a last minute slide. Hayden sent me this morning. He's there with you in the room right now. And basically within an hour wrote his own verifiable index using the stuff in there. So it's definitely possible. Take a look at the design and then come and get involved with, on the GitHub repo with issues and comments and PRs even, and then join us in the Slack channel where you can, we can chat about this afterwards. And so, thanks everybody for turning up and listening. Sorry I can't be there with you, and everyone that got the verifiable index to the point where it is, and whoever asked me questions for being kind, because it's been a long day. I've got a sore throat, and it might be difficult over remote, but that's everything I've got. Thank you.
Have a round of applause for Martin, please. Now, I've been assured he can hear us. Not if you can hear us.
Yeah?
Yeah, absolutely. So we can have some questions. Does anyone have a question for Martin? We have one over there. I will come. You can have to wait while I run across the room. I don't know if you think so.
So this is very exciting. I was wondering if you'd given thought to map functions that can collide, as in, say your transparency log is storing updates to a dictionary. So at any given time, there is a newest value in the dictionary. So in this case, this map function would collide with itself occasionally. And so if you were to query the verifiable index, it could very reasonably return a value and say, oh, here it is in the tree, but it might not be the newest value in the input log. Have you given this any thought? Do you see any solutions to that?
Yeah, I do. In fact, I used to have an implementation quite a long time ago that did do this. The verifiable index is one of the things I didn't have time to get into. It's like a Pareto principle. It's sort of 20% of the complexity that gets 80% of the value, I think, in the space. But what you're pointing at is the sort of 20% that's left. The reason the verifiable index is kind of neat is because it just has all of the indexes there. So you just keep appending to it and you don't have to worry about this idea of latest. The map function name comes from basically the MapReduce framework. And the other part of that, the reduce function that can take a bunch of values and then squish them together and come up with another value, maybe just one of those ones there, or synthesize something new that comes in, is the missing part, I think, for the question that you're asking. And that's explicitly, the reduce function basically here is built in, and it just gets the leaf ID, the index for everything, and then just concats them together. But you could make that also be configurable, and you could still keep it as I think a verifiable data structure. It's just a little bit more complex because various reasons. But if this is something you're interested in, then I'm definitely interested in, this is what I see is like, get the verifiable index out and then move on to something that's more general afterwards.
Wonderful, thank you.
Hey, so it has happened in the past that certificates have been logged in CT with ambiguously incorrect X509 encoding. So I was curious how the system handles that problem where maybe you can't verify a certificate, but it's not clear that nobody else can verify it.
Yeah, this is the complexity of writing. I sort of skipped over that bit, but it is the complexity of how do you write the map function, I think, for CT. And I think something is definitely doable there. One option is that you could have a special places that the key hash that you return could basically encode in its pre-image something about like weird certificate for, and then put those all in one place for humans to also do some manual review over, or other ideas welcome. That's kind of why as I'm a Go developer, I spent a lot of time in this ecosystem, so I can talk somewhat authoritatively to it, and that's why I focused on the sort of proof of concept being there. And I'm kind of appealing, like, I know enough to kind of get through a lot of CT stuff, but like for stuff like this is why we need top CT experts who know and care about this stuff to kind of get involved in helping us craft the perfect map function.
Okay, hi Martin.
Hello Rasmus.
Hi. How do you see this unfold in CT? So should there be one verifiable index per log, or should there be one verifiable index for all of the logs combined, and what are the trade-offs?
Yeah, I mean, so what we have at the moment, you could do an index per log, because that's what the data structure sort of supports, right? But I think you've definitely made the problem a lot better, because rather than users having to scrape dozens of logs in their entirety, you now just have to do lookups in dozens of indexes. But it still feels like maybe you could just have gone that little bit further, right? And make it so that it's just one index, but it makes it a bit more complicated. I mean, at the end of the, yeah, I think the things that you put in the output log wouldn't just be a single like root hash and checkpoint. It would be like a root hash and then multiple checkpoints for all of the logs that are in there. And then you need to update the data structure instead of just being a uint64, because instead of just being a pointer that's just assumed to be at one log, you would need to provide some context about which log you're pointing to as well. And I think those things are solvable. Like, it doesn't keep me up at night, but it seems like it's a reasonable amount of code, and best discussed as a sort of a group of people, kind of to get to a solution. So again, get involved and help us work out how we do that.
It's really cool, Martin. In terms of what you're writing to disk, it sounds like you probably only need to write the new kind of witness for the top of the MPT. So presumably a lot of this is done in memory and it's pretty fast, or do you sort of, how's the performance, I guess is the question.
Yeah, well, so that's one of the things I said. The version that we have, so Filippo ported the AKD implementation across to Go, and that has two implementations. One of them is memory-based and is unsurprisingly fast, and the other version uses, I don't want to misrepresent it, I'll let Filippo explain, but I think it's basically recursive SQLite, and that version is not really fast enough to ingest the CT log from when I tried to do this one. Which is why we've been working with Russ Cox as well, trying to come up with a newer version that is super fast and can be written quickly to disk, and that's sort of something in the pipeline at the moment.
That sounds really cool. Really interested in
that. From the auditor's perspective, it seems easier to have one index per log, because otherwise, if you have data loss of one of the logs, you wouldn't be able to verify the index.
Yeah, exactly. This is sort of what I mean about some of the complexities with it. I think, yeah, like for example, if one of the logs has some kind of a split view type of thing, and then, it will be a fatal error for the log, but then the index has kind of gone past the point where effectively policy says, no, it should have been 3,000 leaves before that, where the split view was detected, and that's the frozen endpoint of it. Things get a bit gnarly, and that's the kind of problem. Like, for example, we need a bunch of people who are experts on CT to see how we solve this problem. Like, it's well solved for a single log to a single index, and the multiple logs to a single index. I feel like it's possible, but it gives me the willies, and we just need to have a conversation and work out, it might take a while to get there, maybe a few failed iterations, but I think this code is pretty easy to kind of iterate on, so hopefully we can find people to do that.
Okay, I think we will leave it there because we are just about at time now. Thank you so much, Martin. It's been great having you here, virtually at least. For everyone who's here, Martin's been chatting away, like he's been watching the live stream all day. He's been very actively contributing to quiz questions. Remember, there's a quiz on Wednesday. So a big round of applause for Martin. Thank you for doing what you can to be with us. We all wish you were here and do miss you.
I wish I was there as well, but I'm here.
Okay, so with that we are now finished for today. I'm just going to reiterate some of the stuff that I think we're finished for today. Like, any organisers who disagree with me, do let me know. But just to reiterate a couple of the things I said this morning. This evening we have free time. We don't have anything scheduled by the conference. So, if you need to sleep, eat, do what you wish. If groups, I think some of you I did send out the list of fun activities in the area that I was sent a while back. So if you want to sort out some of that, do feel free to go and do it. If similarly to last night, I think people really made the most of the Slack channel to let people know when they were going for food, whatever. If you do the same, be inclusive so that everyone, you know, if there are people here by themselves and they would prefer to join a group for dinner, they can. Yeah, do what you need to do this evening. Have a rest if you need to, and we will see you tomorrow. Should have prepared and looked up what time, and the schedule's not in my pocket anymore. Tomorrow morning, I think we start at 9:10. Yeah? 9:10 tomorrow morning. And is that for people who have just told me that? Is that we're starting talks at 9:10? We're starting talks at 9:10. I am talking again at 9:10 tomorrow morning, and then we'll get the talk started pretty soon after that. So it won't be quite as slow of a build up because everyone's already registered and have already got their lanyards and everything. So yes, have a good evening and see you tomorrow.